Conference entitled, "There is no Climate Emergency, Apply the Science and Economics of Development to Stop Blackouts and Death." We've assembled a unique audience of presenters and participants, including you, who are joining us from around the world. We're here to challenge a popularized assumption about climate change, but not through merely asserting its opposite. The particular premise that we are arguing today, climate change, is part of a general premise we are going to contend, that the world has too many people, that mankind has used all the world's resources, and that human progress is the enemy of nature. The person that challenged that premise in the most profound manner over the past half century, from about 1966 until now, was the economist and statesman Lyndon LaRouche, who also co-founded the Schiller Institute in 1984. To begin today's first panel, we bring you an excerpt from a December 1985 address by Lyndon LaRouche.
In our concern to define the exact nature of this self-interest, we search, as did Socrates, for a definition of the good. What is that which served in what manner corresponds to this self-interest? What can we be sure will be beneficial to humanity in present and future generations under circumstances beyond our foreknowledge? How can you know that what you do today can be judged as good, a contribution to the good 10, 20 generations from now? How can you know that? You cannot simply say that I do what my father and mother told me, or what my peers tell me, or what the current opinion poll tells me, and that by acting in such a manner, I believe myself to be good, my friends and neighbors and peers believe me to be good, and who are you to gainsay it? Such definitions of the good are worthless. What is the good as if it were known only by one person, in defiance of the contrary opinion of every other living person? And how could that goodness be proven? That is the question which preoccupied Socrates. What is the good? Man is properly motivated by nothing but the love of the good. That love of the good and its efficient self-service is the essence of individual self-interest. Already this begins to make clear to us, even before the question of the nature of the good is satisfied. It begins to make clear to us that we as individuals are and must be instruments of something universal. That we, as the microcosm of the universe, must become an efficient agency of the macrocosm, of the development of something larger, permanent, all-encompassing, and encompassing in particular the condition and work of all humanity. That our self-interest lies not within our skins, or only as what within our skins is necessary to the work of our self-interest. Our self-interest lies in the good, in something universal. That is our work. That is our self-interest. And that some people have understood. What is the good? How can we observe the good empirically? Well, first we look at the difference between ourselves and the beasts. And then we have to study economics, not the kind that is preached in Washington or in the universities today or by the so-called economics profession, but physical economy, real economy. The power of a species, of an individual, to produce the material and cultural conditions necessary for the existence of that species. And what's the difference between us and the beasts? A very simply observed distinction. Well, at least historically, if you can't observe it in the current crowd in Washington. That in the earliest condition, as asserted by the all-knowing anthropologists of mankind, it required, on the average, the order of 10 square kilometers of the surface of the Earth to sustain one individual in a very miserable condition of life. The average age, in terms of life expectancy of that individual, would be considerably less than 20 years. The existence of these small groups of individuals, sort of extended mother-dominated family groups, the old mother of the tribe, probably 28 years old, would dominate a mass of little children, squabbling children, who behaved and thought very much like beasts. And the existence of these little groups would be extremely precarious. And there could be not more than approximately 10 million such miserable creatures, living an existence more precarious than that of a tribe of baboons upon this planet. But today we have approximately 5 billion persons, and who, apart from liberals, live on a much higher level of existence than the baboons. How did we get there? Herein lies the distinction, the empirically demonstrable distinction between man and the beasts. We got there by what we call today scientific and technological progress, which takes the form of scientific discovery by which we are guided to modify our behavior. That is, we do not behave according to what Adam Smith prized as original and immediate instincts, but rather we suppress those bestial baboon-like instincts in order to bring forth some other quality which we have within us, the quality of creative reason, the power to look up to the heavens and construct a solar astronomical calendar, as opposed to the kind of lunacies which came out of Babylonia, which is done very simply. Man looked up, took some sticks or stones, did the obvious, took the angle of the sunrise, the angle of the sunset, and the highest position of the sun during its midday course. Elementary. And then man did something also very obvious. He stayed up at night, a thing which I tell you is essential to wisdom. You have to wait until the world's asleep and then think about what happened. And then the next morning you've got the world off guard. That's wisdom. You stay up at night and you take these sighting positions of the sunrise, the sunset, and the midday position, and you observe to which constellations and stars do these observations correspond. And so on stone, like these megalithic constructions which were made, dot the Brittany and Ireland and Britain, typified by Stonehenge. So you simply mark by day, and you can count the days by the sun, not by lunacy. You count the number of days. In 5 years, you discover that in the cycle of the advance and regression of the position of the sun, and man would obviously use the equinox for this dating of the calendar, that there are 365 and a quarter days approximately in one cycle called 1 year. And then you discover by the same means other cycles. A beast can't do that, nor can a liberal. Only a human being can do that. And the earliest known cultures dating 6, 7, 8, 10,000 BC, the earliest known cultures developed a solar astronomical calendar, which is more accurate than anything that existed up into the 19th century, and also which far surpassed anything created from the founding of Sumer and Ur in the biblical land of Mesopotamia, which is a biblical fraud, written by Babylonians who rewrote the old Jewish writings under orders of Babylonian Chaldean priests. So man is capable of this, capable of reason, capable of seeing lawful ordering in the universe and using the knowledge of that lawful ordering to reform and change his own behavior. And in this way, by making reason rather than Smith's immediate and original instincts, bestial qualities, the characteristic of human behavior, by so doing, we achieve what we call scientific and technological progress. We not only increase man's power over nature by bending man's will to the law of reason in the universe, by making the mind not the bestial aspect of humanity, the personality and the value, the identity, the person. We not only increase the human population, but we elevate the possible moral condition of mankind if we don't have oligarchs to ruin the process, usurers, Venetian bankers, and the like. Then we begin to discover what is the good. What is the good? The good is the power of mind to recognize a principle of reason as the lawful ordering of the entire universe. To recognize that a process of development is associated with this, and to recognize that the continuation and acceleration of the takeover of the personality by elaborated reason is the good. The elevation of the moral condition of mankind in correspondence with this principle and in actions congruent with that principle is the good. Such was the principle of Solon at Athens. Such was the principle of Platonic Academy, the concept of the Republic. And such were the principles of the founding of the modern European Republic by the writings of St. Augustine. That is the good. And the Republic is the only natural condition of mankind. And it was proven by Dante and his followers that the only natural form of republic is a totally sovereign nation state, not subject to the IMF or the World Bank or UNO, a sovereign nation state, a republic which is based upon the employment of a literate form of common language by its citizens. A literate form of language which imparts to those citizens, as in the words of Shelley, the power of imparting and receiving profound and impassioned conceptions respecting man and nature. Conceptions organized in the form of reason. The form of reason is exemplified by the Socrates of Plato's dialogues.
Good morning, good afternoon, or good evening, depending on what part of the planet you're observing this conference from. I'm Diane Sayre, and I will be co-moderating this first panel with Dennis Speed. Those of you who joined at the beginning may have noticed that Dennis was moderating the beginning of this panel. This is the first panel of a two-panel conference titled There Is No climate emergency. And the title of this panel is The Economic Effects of Green Mad Mutually Assured Destruction. And what I would like to do now is to introduce our first speaker, who was a longtime associate of Lyndon LaRouche's science team, Jason Ross, on There is a Limit to Renewable Energy.
Okay, thanks, Diane. I'm very happy to be here. This is going to be a very exciting panel and conference. The outlook that is attacking us right now, the green outlook that says that there's a green outlook and anti-human ideology that says people are the problem. This is exemplified by people like Paul Ehrlich, the author of The Population Bomb, who denounced the idea of nuclear power later in his life after writing that book, saying that having unlimited clean power would actually be a bad thing, not a good thing, because then how would we limit growth if we didn't have these resource constraints? So let's talk about our relationship to the environment very briefly. Do we go around looking for food, or do we plant it? I mean, what do we do as a human species? Do we hope that we'll get the right amount of rain, that it won't rain too little and cause a drought, that it won't rain too much and cause a flood? To what extent do we worry about that versus having water control infrastructure? I mean, increasingly, obviously if you're farming and you don't have irrigation, you can't help but worry about that. But in many contexts, because we're able to transform and improve that environment around us, we don't worry about it as much as we used to, except when we do get a very heavy amount of rain, and then we say, hey, why didn't we build better flood control? Or if we're stupid, we say, oh, look, this is carbon dioxide. Nope, floods happen. They've happened for a long time. The question is, how resilient are we against them? What's going to kill somebody in terms of weather? A temperature increase of a degree or two over a century, or not having air conditioning on a particularly hot day because you're in a blackout? Okay, how about science and technology? Do we hope that it will advance, or do we invest as a society through our government in science driver programs, in a space program? Do we ensure that the kinds of technological and scientific breakthroughs that we're going to need to advance to the next level of production and infrastructure do indeed exist because we're driving them forward? You know, we make these things happen. The green idea is essentially a religious one, a very inconsistent religious one. We are told that carbon dioxide, increasing carbon dioxide, is going to cause climate change of invariably a bad sort. It's odd that none of the changes that carbon dioxide is going to engender are good. Everything it does is supposedly bad. Now, is that really possible or likely? If we look at the changes in weather, we find that we do not have an increase in weather-related deaths or weather-related property damage as a portion of the economy as a whole. It's decreasing. Is it because the weather's getting better? In some respects, yes. Over the last century, or last few decades, for example, tornadoes have gotten better. Over the last century, we see a trend in hurricanes. It's not a bad one, it's a good one. But the real change is that we changed, okay? People worry, is the climate changing? Well, how are we changing? How is our relationship to the climate changing? How is our susceptibility to climate problems or issues or weather issues changing? We're very much in control of that, and we should increasingly be so. So one of the biggest giveaways on this is the view of nuclear power. How can people who believe that carbon dioxide emissions are literally threatening, jeopardizing the entire planet, creating the potential that by 2030 we will unleash a chain reaction of devastating consequences that we can never reverse, the genie will be out of the bottle, how can you believe that and consider yourself knowledgeable about the entire Earth's climate, a pretty complex system, I'd say, and still be a moron on nuclear power? How could you believe that you know everything about the Earth's climate and not understand the basics of nuclear power or how safe nuclear waste is? It's about the safest form of waste from power that exists. Far less waste from a nuclear plant than from a windmill, for example. What do you do with all the wind waste, the solar waste? People don't think about that. But how could you have that as your goal and ignore the power source that is, doesn't make any carbon dioxide, is dispatchable, you can use it when you need it, you can count on it rather, it's reliable, and that exhibits a higher energy flux density than coal or natural gas, or certainly those pathetic ones in the back of the pack there, wind and solar panel. So the goal that we have to set ourselves is to advance, to develop, to make ourselves less susceptible to the uncertainties of nature, something that we have done as a species overall through our existence. We've decreased our dependence on the day-to-day changes that exist in the weather. And really what we have to always keep in mind is that we are not an Earth-based species. We may live here right now, but we're certainly not an Earth-limited species. So what are our goals about industrializing the moon? What are our goals for in-situ resource utilization there? Setting up research facilities. The far side of the moon is a wonderful place for a radio astronomy. The ability to set up a large artificial aperture through a series of ground stations back there, protected from all of the noise coming from the Earth. It'd be a wonderful opportunity. What else does the moon have? An isotope of helium, helium-3, that is very well suited for nuclear fusion as a fuel source. That's an export from the moon. It wouldn't be worth bringing gold back, but that certainly would. So what are we thinking of in terms of where our future is going to go beyond this planet, in terms of setting up, whether it's manned by people initially or other automated bases for research, etc., on Mars? What additional craft are we sending there? Are we developing nuclear energy, nuclear rockets, so that we will be able to protect our planet from a real threat to the planet, which is not plastic straws or carbon dioxide, but asteroids? We're a sitting duck right now. And if we do not develop more powerful types of energy to have under our command, we'll continue to be susceptible to an asteroid wiping us out, knocking us out. So I don't want to say much more right now to open up. I'm going to have some more thoughts to add later, but I think that we've got a really excellent panel here today that's going to take up a lot of these issues about, what are the changes in weather, what is the science about carbon dioxide, what is the reality of nuclear power, and I think we're going to be able to have a very good discussion about all of this. So that's what I have for now, Diane.
Great. Well, thank you very much. I think what we'll be discovering today is that many of the problems in society are caused by the fact that we are afraid of the wrong things, and we're not embracing the things that are actually good for mankind. Our next speaker is an Emeritus Professor of Geophysics, member of the Netherlands Academy of Sciences, senior member of the Dutch Academy of Engineering, and the president of Clintel. His name is Guus Burgholte, and his topic is Stop Blaming Climate Change for Your Failures.
I am Guus Burgholte, and it is a great pleasure for me to tell you what we have learned from the recent flood disaster in Europe and in my country, the Netherlands. This is the message of Frans Timmermans. He is Vice President of the European Union and responsible for the climate policy in Europe. As you see, he blames all misery to climate change. And he concludes, we urgently need to increase the investments in climate mitigation by CO2 reduction. Timmermans and his allies tell us that by simply turning the global CO2 knob, we can control the temperature of our planet. And they repeat that over and over again. Now the question is this thermostat knob narrative far-going ignorance, or excessive arrogance, or is it part of an ideological master plan? Let us have a look. Europe's modern water management infrastructure is still inadequate. The serious July 2021 floods were a very painful reminder. But this is not new. We already found that out during the major floods in the early 1990s. Just like then, today the green politicians blame CO2 emissions. However, instead of blaming themselves, the Greens blame the headstrong citizens and entrepreneurs who just do not want to be climate neutral. They are just trying to cover up for their own failures. And I will show you that. This message was extensively explained in a one-page article in the largest Dutch newspaper, De Telegraaf. See the picture on the left. Now, an important question is, are Europe's July 2021 floods unique? Let me give you a short historical review, and I make use of my German neighbors, because they were always very gründlich in registering the flood levels. Here, a very notorious picture of the Christmas flood in Germany and the Netherlands as early as 1770. It was a very famous flood with a lot of casualties. And when we go to 1784, you see a picture of high water in Würzburg. It looks like a very big disaster. And let's go to 1888, where we see a picture of the Dargau Hochwasser. Now, a very nice overview by a timeline at the wall of the town hall of Passau. Note the high flood level in 1500 and 450 years later, 1954. And note also the very large variability in flood levels in the past 500 years. And then here another small town in Germany. Again, history shows that high water levels and flooding have occurred many times over the centuries. Look again at the big differences. Now, to attribute past and current flooding to CO2 emissions is most questionable. I come back to that. Well, keep in mind that all this historical information is known by authorities. So they are not ignorant at all. However, instead of acting, they are just concerned with investing in CO2 reduction. Let's go to France. And here you see a picture of the Paris flood in the early 1900s. Well, it's interesting that around the same time, there were big floods in the western parts of the United States. At the same time in the world, you have big floods in Europe and you have big droughts in the United States. And we have seen that over and over again. Here a picture of the 1954 flood in the Netherlands with a lot of casualties. It initiated the well-known Dutch Delta works. They were particularly for the Dutch coast. Now I show you the situation in southeast Netherlands a couple of weeks ago. The situation along the Dutch coast and major rivers is in order because of the Delta works. However, a lot of work is still to be done on the canals, tributaries and local streams. A plan is already available for many years. So why do green politicians pour billions of tax revenues into biomass plants and wind turbines instead of investing in badly needed locks, pumping stations and inland dikes? I can tell you the Dutch are so shocked about the floods because they know how to prevent them. Now, keep in mind, there were many different causes of all these flood disasters I showed you. But it is very unlikely that Even one of them was caused by CO2. Keep also in mind that the periods of flood were alternated with periods of drought. We saw that already during the Paris flood in the early 1900s. Here a picture of the Hungerstein. It's in Germany. It says, it gives different marks, but it says, "When du mich siehst, dann weine." When you see me, then cry, because it means that the water level is very low and we are in the midst of a drought. And at that time, a drought meant Hungary. Let us look at these two pictures. The left-hand side shows that the climate-related deaths decreased dramatically during the past 100 years. And that was due to adaptation. Many facts show that it is not climate mitigation, CO2 reduction, but climate adaptation, timely adaptation, that has resulted in a spectacular decline of climate casualties in recent decades. Now, if you look at the right-hand side, you see a picture where it is shown that CO2 levels are increasing. And you see also that many conferences were arranged by the United Nations to try stop this increasing CO2 level. But you can also see after 25 of these expensive conferences, nothing happened. But we also know that all these extensive and expensive measures against increasing CO2 has never saved one life. So why have political leaders not learned anything from this knowledge? All they seem to be doing now is holding meetings about reducing CO2 and forgetting to take the measures we are sure will work. Now, of course, we cannot say the more CO2, the less climate-related deaths, because more CO2 has a completely different cause than the decreasing climate-related deaths. So you cannot just say that more CO2 causes less climate-related deaths, or the other way around. It's actually ridiculous. But keep in mind, a similar fundamental cause-effect mistake initiated the founding of IPCC. Let's go to a conclusion. Climate adaptation provides high benefits at low cost. That's a fact. So why is this not done? Why are green politicians still talking about high-cost CO2 mitigation projects? Why do they still pour billions of tax revenues into biomass plants and wind turbines, instead of investing in badly needed locks, pumping stations, and inline dikes? Dear citizens, please wake up. We understand the problem. We know the solution. We have the technology. We also have the money. So where are we waiting for? And keep in mind, when I say problem, it's not only a fight against flooding, but it's also our fight for a safer living environment in general, and a better education, and more independent scientific research, etc., etc. So what is the next logical step? My urgent advice is, don't allow green politicians to spend our money on ideological CO2 projects. They actually have the least priority. And be aware, if we do nothing, the flooding in Europe is a harbinger of the future for the entire world if the Great Reset comes into force. Ladies and gentlemen, I sincerely hope that the July flood in Europe will open up the eyes of the green politicians and will have a major effect on their priorities on our future, because we talk about not their future, but our future. Thank you very much for listening to me.
Thank you very much, Professor Burgholte. If you've just joined us, welcome to today's special conference of the Schiller Institute. There is no climate emergency. Apply the science and economics of development to stop blackouts and death. Our next speaker is State Senator Mike Thompson from Kansas. He's the chairman of the Kansas Senate Committee on Utilities, but he was also a weatherman weatherman, I should say, for 40 years. For those of you who think that you do need a weatherman to know which way the wind blows, this presentation is for you. His topic is Reverse Course on Wind and Solar, a report from the United States Central States.
Hey everybody, Mike Thompson here. I'm a senator from the 10th District in Kansas. Once again, very happy to be here as part of this forum. Particularly for the distinguished guests from all over the world. We've got a great discussion today, and hopefully my part will contribute a little bit. Just as my background, I didn't get into politics, or didn't intend to get into politics. I was a meteorologist for over 40 years, mostly on television, but to some degree in the private sector. And so the weather and the climate is one of my fields of expertise. One thing I also had studied over the course of that time period, particularly since about the year 2002, was the energy issues. And so when I ended up in the Senate in Kansas here 2 years ago, that was one of my big things that I was concerned with. And really, we're making a lot of energy and policy decisions based on false climate information. And so as not to really step on some of our other experts here today, I'll try to focus just briefly on the climate and some of the things that I'm seeing that are being utilized propaganda-wise to steer us in the wrong direction in a lot of ways. And we're seeing Kansas as a microcosm of the issues that we're going to be experiencing nationwide if we continue this proliferation of renewable energies across the country, because we're seeing some real distortions in our energy markets here in Kansas. And so I'll share a little bit of that with you here in a second. So I'm going to share my screen very quickly and go into my presentation. So I'll just start it off here from the beginning, if I can get us go. Basically, what we've done over the last 30 years is weaponized science. It really started off with Al Gore and his inconvenient truth. It was going before that, but that's when it really went on steroids. So we've literally replaced real science and real reliable, sustainable energy sources and real clean energy sources with this. Just basically nonsense. People who are using the climate to their advantage, and the fact that a lot of people don't understand the climate or the science of climate to promote some very bad policies. So we're replacing science with a social narrative. And here, just one thing we're doing, we're killing all sorts of birds and bats, and you've heard about this from Michael Schellenberger, to save the planet with these renewable energy sources. And it makes no sense to me at all. Here is the mix of the generation from the Southwest Power Pool, which is where Kansas is part of that regional transmission organization in the Central Plains, during our polar vortex in February, where we had a lot of power outages. Texas really suffered, but look at what was providing the power for us then. The orangish yellow is the natural gas. That was 34% of the generation. Coal provided over 50% of the generation. Nuclear, we've got one nuclear plant out here, actually two. There's only about 6%. But that's all it can, because that's part of the mix. But you'll notice wind dropped to about 1%. The variability in the wind is the big problem out here, because what it's doing is undermining our base load plants. And I'll get into that in more detail here in just a few minutes. The reason we're going that way is propaganda. carbon and CO2 are deliberately used interchangeably. You think of carbon and you think of black sooty substances. Well, even though carbon and carbon dioxide have carbon in the name, they have completely different properties. It's like saying soda pop and Pop-Tarts are the same thing. It just doesn't work. And here's why. CO2 is colorless, odorless, it's essential to life. It makes plants more drought resistant. It makes them hardier. It makes them more productive. And it's been shown by various agricultural studies that the CO2 levels should be about 3 times higher than they are right now for plants to continue to thrive. It is a secondary greenhouse gas. Water vapor does most of the work, and I'm sure some of our other experts will be talking about this in more detail. But here's how minuscule CO2 is in the atmosphere. It is less than 1/2 of 1/10 of 1% of the atmosphere. And it's 1/1000th of all of the CO2 on this planet. Most of it is in the ocean, in the soil, in the rocks. And so, you know, somebody will talk about, oh, we're going to be dumping 50 metric tons into the atmosphere. That's a drop in the water. It's like saying I'm going to spit in the ocean and cause the oceans to rise. And CO2 is, we've got enough of it right now that it's absorbing all of the infrared radiation that it's capable of absorbing. In other words, at this point, we could double, triple, quadruple the amount of CO2 in the atmosphere. It would have zero impact on the temperature of this planet. And a lot of people don't understand that, but CO2 does not absorb all of the infrared spectrum, only a very tiny portion of it. Water vapor handles the stabilization of the temperature. So CO2 just piggybacks on the influences of water vapor and on the sun. And of course, volcanoes and the ocean contribute far more CO2 to the atmosphere than man does. The sun really controls the climate. The sun is 1,300,000 times the size of this planet. And although you look up in the sky, you see what looks like something the size of a quarter, it's hard to imagine how big that thing is and how much it influences us. But any fluctuations in the solar output at all have a huge influence in the weather on this planet. And if you look at the total solar irradiance since the Little Ice Age, we came out of the Little Ice Age in the 1700s into the early 1800s. The sun woke up after a period, and this is part of a natural cycle process. And you see that since 1800 and particularly 1850, the sun became more energetic. This is why the global climate alarmists use or stop looking at data prior to 1850. They use that 1800 to 1850 time period as their starting point because they know that's when the sun got more energetic and started sending more energy our way. But now we're going into a part of the solar cycle. There's a 210-year solar cycle, and we're going down to the back end of it. So solar physicists are now looking at a downward path for the energy of the sun over the course of the next 20 to 30 years. And in fact, we're seeing a very quiet sun at this point. Weather also is not climate. They use those two interchangeably. A weather pattern like this heat wave that we're having over the western United States is not due to a climate change. The climate is not changing significantly. Yeah, it's hot out there right now, and it's due to a weather pattern. But climate is not changing. This winter, I guarantee you, Minnesota is going to be colder than Florida. And although it's hotter in parts of the northern plains right now than it is in other areas, that's due to the fact that it's drier up there. Dry air in the Pacific, in the Northwest and over the high plains of the West, dry air heats and cools at 2 times the speed of humid air. That's why it doesn't heat up as much down in the coastal areas of the Gulf and along the eastern seaboard as often, because if the humidity is high, it just keeps the temperatures from climbing quite as high because it doesn't heat up as fast. And NASA and NOAA have been correcting the temperature arbitrarily for a long, long time. They did a number of reanalysis of the atmosphere And if you compare that with the raw data, the raw temperature data, you'll see that the raw data in the orange actually is on a downward trajectory, whereas the corrected temperature data, and I use that corrected in quotes, shows us on an upward path. And so we have been fed false information. I don't know how they come up with this correction. It's a subjective and arbitrary path. But in other words, we're being fed that we're putting too much CO2 into the atmosphere is getting hotter, and therefore we've got to make all these energy choices. We've got to get away from fossil fuels. We've got to get away from nuclear and everything else and go toward these renewables because they'll save the planet. And that is the false narrative. In fact, in Kansas City, we've not had a 100-degree day yet in over 3 years. And you look at 1936 down there, we had 53 days over 100 degrees. The carbon dioxide level was 100 parts per million lower than it is right now. The oceans also determine the weather patterns on this planet, and they can be profound. Remember, it's 71% of the Earth's surface, and you can see the very warm, here's a very strong El Nino. When that happens, not only does it release massive amounts of CO2 into the atmosphere, it changes the weather pattern. Here's a cold Pacific decadal oscillation. Look how much colder the Pacific is here in 2008 than in 2019. These are huge pattern shifts that we see constantly. They're very slow, and they affect the weather pattern around the atmosphere. And so it's affecting the weather pattern and giving us the heat wave that we have out west right now. So we're heading in the direction, energy-wise, that California's already led us. Do we follow? Well, California is now a net importer of electricity. 32% of their electricity has to come from other states. So they are reliant on everybody else because they put all these renewable energy sources into play. Kansas, we're paying dearly for it. I skipped one accidentally. I don't know if I can go back one. There we go. In Kansas, we had only a very small percentage of wind prior to 2005. But after that, this is the implementation of wind energy in Kansas. And look at where our average retail prices of electricity have gone. And this is a scale of 0 to 100%. Our retail electricity prices across the board in Kansas are 70 to 80% higher as a result of the implementation of wind. We've added no extra generation sources other than wind in significant sources since that 2005-2007 time period. So it all goes to the infrastructure required for wind, the transmission lines, the extra generation capacity. We're replacing our dispatchable power sources, the ones we rely on, the nuclear, the coal, and the gas, with the wind and the solar. And the wind's intermittent and variable. It doesn't blow all the time. We can't control when it blows. In fact, it usually blows when we don't need it. And that creates a distortion in the energy market. And the big important thing to understand about wind is just because you may see a turbine turning in the wind, it does not generate that much electricity. Less than 10 miles an hour, it's actually using more electricity than it's generating. And the rated speed, which is where it produces what it's supposed to, almost never happens. Here's a power curve of a couple wind turbines. These are 2.5 and 2.3 megawatt turbines. And you'll notice they list across the bottom the wind speeds in meters per second. So I've annotated what those mean. You notice they don't reach their peak power until about 11.9 meters per second, or 12 meters per second. That means the wind has to be sustained at more than 25 miles per hour during an entire day for those wind turbines to produce what they are designed to produce. You'll notice at lower wind speeds, under 9 miles an hour, even under 15 miles an hour, which is 7 meters per second, that it's not even half of what those wind turbines are supposed to produce. Here's another power curve of some other, and they're very, very similar. So how many days a year do we have 25 mile an hour sustained winds? And so I went back in 2016, 17, 18, and you'll notice this is at Kansas City International airport. Over 200 days per year, we have less than 10 miles per hour wind, which means any turbines sited around here are using more electricity. They're a bigger electrical client than they are a generator. And we only had 30 to 40 days where the wind was at least 15 miles per hour, which means that it was producing less than half. We had 0 days in those 3 years, and I could probably update this chart for any year that you want, and it's going to be very similar. We rarely have, out here in the windy plains, days that we have sustained winds at 25 miles an hour for an entire day. Here's Gardner, it's on the southwest side of the metro, similar numbers. Topeka's even worse in those 3 years. No days, the 25-mile-per-hour winds. And as a result of adding all this turbine capacity across Kansas, we have about just under 20% of all the transmission line costs of the entire Southwest power pool are borne by the ratepayers here in Kansas. We also have to put more peaking natural gas plants into play to compensate for the wind. Wind doesn't blow. And there are environmental issues. Each of those turbines contain about 1,000 pounds of these rare earth minerals, neodymium and dysprosium. They are primarily mined in China, and they leave behind an equivalent amount of toxic radioactive waste. So all the environmental reasons for going to wind get thrown to the wind by these. We have turbine failure safety concerns. We have the turbine lifespans are overstated. In Germany, where and other places in Europe where they've had the wind for a lot longer than we have, the turbines wear out much faster than the stated 25-year lifespan. It's more like 12 to 13 years. And the blades typically only last about 3 years, and we're putting them in landfills at huge cost to us. The efficiency rating of a turbine drops by 24% in the first 12 months. And the operational efficiency of these turbines is down to about 11% after 15 years. And that's just because of the wear and tear on the nacelle and the engine inside the nacelle. And of course, we subsidize solar and wind more than anything else. So the reason they're able to operate is because of these subsidies. We have other wind power concerns. There are oftentimes we have to pay these things to shut down because there's too much wind when we don't need it. There are decommissioning costs that are underestimated. In fact, we think it's about $1 million per turbine to take one of these things down and restore the land. So with over 3,000 turbines in Kansas right now, we're talking at over $3 billion in decommissioning costs, and we don't know who's going to pay that. A lot of landowners like this because they get paid, but there's a lot of legal issues that they have to be considered with that they probably haven't thought about. And just some final thoughts, just from my experience in looking at this, we should require bigger setbacks. In Bavaria, they require 10 times the height of the turbine, which would be over a mile. Require specific time of day bids for electric delivery. That would help to undermine the wind coming on and clearing the market before any of the other sources. Require bonding and escrow for decommissioning. Require full restoration costs for the land. These turbines don't pay property tax. They pay a payment in lieu of tax. So we need to have them pay their fair share on the property tax. We need to look into reliability requirements, ensure base load plants can compete. This is the big problem for us. We're retiring coal plants out here because the wind is so heavily subsidized that when it does come online, it competes directly against the coal and the nuclear and the gas plants and clears the market before they can even get online. So we are paying, those plants are paying to operate, they're paying people to be employed, or keep their people employed and run our lights 24/7 so that we can accommodate wind. It's just completely backward. The wind should only be a supplemental source of electricity. I can see that I've gone way over my time. I'm very sorry about that, but I appreciate the opportunity to speak about this. This is a subject that we've got to be aware of nationwide. Otherwise, we're going to continue to make some very, very bad choices in energy policy and other policies, all based on false science. And I very much appreciate your time, and thank you for your indulgence and patience.
Great. Thank you very much, Senator Thompson. I would like everyone who's watching to know that our panelists will be available at the end of this section for questions and answers, and you may submit questions to questions@schillerinstitute.org. So please feel free to do that. Our next speaker is Professor Francesco Battaglia from Italy. He's a professor of physical chemistry from the University of Modena. He's a member of the initiating committee of the Petition on Anthropogenic Global Warming from June of 2019. And his topic will be "The IPCC is Wrong and the Consequences Are Deadly."
Okay, the presentation is titled "There is no climate emergency," and there is no climate emergency is also the title of a petition which has been sent by about 1,000 world scientists to the United Nations. The first signature has been the one by the Physics Nobel Prize Ivar Giaever, 1973 Nobel Prize. Why there is no climate emergency? First of all, I must say that it is not even plausible, because the worry is that the concentration, the CO2 atmospheric concentration has been increased by 100 part per million, 100 ppm, since the beginning of the Industrial Revolution, the last 200 years or so. However, if you are in your living room, let's say 5 meters by 5 meters by 4 meters, it's 100 cubic meters, and 100 parts per million is just 10 liters. So if in your living room you light up this candle, the amount of CO2 which is put into your living room is just the same amount that has been put by the all human activities over the whole world over the last 200 years. So it is not, that's what they say, it is not even plausible. There is another reason why it is not plausible, is because climate is a very, very complex system, and to this and many tens of parameters rule the climate. So the idea of ruling the climate just taking care of just one single parameter, which is CO2 concentration, is really not plausible. Anyway, besides plausibility, these are the facts. The facts are that during the last 400,000 years, the Earth has suffered periods of glacial periods and interglacial periods. Every 100,000 years of glacial periods, there has been about 20,000 years of optimum climate. Now, here we are. This is where we are at the present. 100,000 years ago, 200,000, 3 and 4. As we see, the temperature now is below the maximum temperature it was in the past climate optima. And the CO2 concentration now is here, out of scale. We are at 400 ppm, part per million. Yet the temperature is below, of the past temperature. So a climate so warm has happened in the past, even though the CO2 concentration in the past was not as high as the one today. If we go closer to our times, these are the last 12,000 years. Since the last glacial period, the temperature has gone up about 10 degrees, and here we are, and we see that there has been a medieval warm period, a Roman climate optimum, a Holocene climate optimum, with temperatures which have been higher than today. And this can be seen also in this graph where the extension of the Alps. Here we are in the past. The glaciers in the Alps have been reduced by this amount in the past. Here is the medieval warm period. This is the Roman warm period. Here are the years when Hannibal went through the Alps carrying his soldiers and elephant, a business that he couldn't have performed if there were high extension of glaciers. Here is the Little Ice Age, which you will see better now. Okay, these are the last 1,000 years. Here we are. This is the medieval warm period with a temperature higher than the one of today. And this is the Little Ice Age. The minimum of the Little Ice Age is around 1690. Now, since then, the temperature has come up. So the temperature has risen since 300 years ago. But for about 2 centuries, human activity could not have anything to do with this warming. So why this warming? So actually our warming is the warming that comes from the fact that we are coming out of the Little Ice Age. Somebody says that the Little Ice Age and the medieval warm period were just local. And this is not true. In this picture, the red spot are the spots where there have been research results that have shown warmer temperature during the medieval centuries. And this warmer temperature has been shown to be so all over the world, not just in the area of the Alps, but all over the world. And this is the period of the Little Ice Age. We said around 1700. This is the Venice Laguna, with ice, with people who were skating on the iced Venice Laguna. And here is the London Thames with carts and people walking on the iced river, with frozen fairs which were happening every winter during that time. The last frozen fair in London was in the year 1813. Now, this is about the Little Ice Age, which was a global phenomenon. Indeed, this is the solar activity. This minimum around the Little Ice Age period, the astrophysicists call it Maunder minimum, where there is a minimum in solar activity, and in correspondence to this minimum, there has been a low temperature all over the planet. Now, let's come down to the period after the Industrial Revolution. it is true that the temperature has risen. This is true. And as we said, actually, it started rising since the years of 1700. And so, because we are coming out of the Little Ice Age. However, here, what we see here, the temperature increases here, but then between 1940 and 1980, the temperature stays not only constant, actually decreases a little bit. This were the time when there was a baby boom, industrial boom, and emission boom. Emissions were booming after World War II. Yet the temperature was coming down. It was so worrying that one could read this magazine, an American magazine of 1969, where they, on the first page, they say, experts say a new ice age is imminent. And this is the first time when the Time magazine came out in color, and the title of the front page of the Time magazine is The Big Freeze. Now, what happened after 1980? And after 1980, the temperatures started to go up again. Yet, during the years 1998 until about 2010, the temperature has stayed constant. Here, this is because of what is called El Niño, which is a phenomenon of hot, warm currents under the sea, under the ocean, which has nothing to do with CO2. But if we don't take account of the El Niño, the temperature for about 14 years stayed constant. There was actually a little bit of cooling, yet the emissions were increasing without stopping. Now, there is another contradiction. What is this? This is the atmosphere. Here on the left we have the North Pole, on the right we have the South Pole, in the middle we have the equator, and then if we go up, in the sky in the troposphere at around 10 kilometers above the ground level. There was supposed to be a hot spot according to which the temperature, because of the man-made global warming, the temperature was supposed to be here in this region, 10 or 12 kilometers above the ground around the equator, was supposed to be 3 times warmer than the warming on the ground level. This was the prediction. What was the reality? When the temperature was measured by satellites and by thermometers on balloons, and the atmosphere was mapped, the atmosphere temperature was mapped, this is the results. At around 12 kilometers above the equator, in the equatorial troposphere, not only the temperature has not been higher than the one in the ground, not to mention 3 times higher, but it has been cool. It is cooler over there. So this was granted to be as the fingerprint of anthropogenic global warming. It turned out the facts have turned out to be that this is actually the fingerprint of the fact that the global warming is not anthropogenic. And they made a mistake also. These are the spatial pattern, no? In space, pattern in space of temperature. The results are in contradiction with the prevision. And these are the prevision in time. About 20 years ago, the models, the same models that have failed on about the space pattern, have failed also in the time pattern. Why? Because they had predicted that the temperature, the global temperature, should have been higher, should have risen as much as this, the red curve in the future. This is the predictions. Now, the observations from satellites is this. So, as we see, there is a great gap between prediction from the models which claim that the global warming is anthropogenic, and what is the reality. Where has been the great mistake? The great scientific mistake is the following. They say, we have our model, which are mathematical models, quite complicated, and they say, if we put in the model only natural forces, we find that the temperature should go as this blue band goes. This black curve there is the actual observation. However, they say, if we in the model include the anthropic contribution, we get this pink band. This pink band is in agreement with the black observations. No? The blue band was not in agreement, is not in agreement with the black observations. So the blue band does not include the anthropic factor. Then this warming is due to humans. This is a very great scientific mistake, because what is going on here is the following, that the models could instead be wrong. The models could be wrong. And this is why the models do not model the right temperature. And this mistake, they have corrected artificially the mistake, just tuning the correction so that to make the blue band coincide with the black curve. This is what they could have done. How can one decide if they did so or not? The only way to do so is to compare the models with when there is only natural forces, with a time when there were only natural forces, mainly in the past. Now, what happens when the models are run aiming at reproducing the past temperature? And the results is this. The red are the data in the past, and the blue are the data from the models, the results from the models which of course do not include any human contribution, because at that time there was no human contribution. But this shows that the models are wrong. If one goes further in the past, in the Holocenic optimum, the blue and light blue curve are the facts, the experimental temperature. And this yellow and the black lines are the results from the models. There is a disagreement between what the model, the models compute and what is the reality. So the models are wrong. Now, there is another big fear. The big fear is that these human emissions, this increased CO2 atmosphere concentration might increase the number in number and also in intensity the atmospheric the hurricanes, for instance, the severe weather phenomena. Now, the severe weather phenomena can be counted. One can count. And indeed, here we see between 1851 and 2010, divided by decades, the number of hurricanes which have hit America, organized by category. 1, 2, 3, 4, 5. Now, one can count all this. I make the count for you. And the result is that the hurricanes in America, during the 80 years between 1850 and 1930, have been, those of strength 4 have been 10. And the 80 years between 1931 and 2010 have been 8. And those of strength 2, 3, and 4, 85 against 83. And all together, they've been 149 earlier and 135 later. So this shows that indeed the hurricanes have been less when the weather was warmer than when the weather was cooler. Now, I'm a scientist, and I think that this is a simple statistical fluctuation. But this can never be solved as an increasing of hurricanes. That's for sure. Now, the European Union and also now America with the new president, they want to reduce the CO2 emissions. The Europe, for instance, has the aims at reducing the emissions by 50% in the next 10 years and by 100% before 2050. Now, this is not the first time they have this kind of dream. There was the Kyoto Protocol. The Kyoto Protocol wanted to reduce the emission by around 5%. In comparison with the emission of 1990. And the Kyoto Protocol was in force in 2005, and before 2012, the emissions should have been reduced by some measure. I don't know. They said 5% by those who had signed the Kyoto Protocol. But what happened to the emission of the world? The emission of the world happened that between 1990 and 2012, the emission of the world had increased by 50% here. And today by 60%. The European Union in 208, when was very clear that the Kyoto Protocol had failed, because the emissions at that time were increased by 40% in comparison to the emission of 1990. In 2008, the European Union came out with what is called the 2020 climate package. The aim was to reduce the emissions by 20% by 2020. But the emission, and they did so, even though the Kyoto Protocol was definitely, without doubt, failing. Now the emissions are today 60% higher than the emission in 1990. So what is the United States doing? Well, the United States, between 1990 and today, has increased its emission by about 3%. So the United States have not reduced the emissions. Just, it stayed almost constant. A little increase, 3%. However, China and India are increasing by 350%. And India has a population which is 3 or 4 times higher than Europe. So Europe gives a contribution of less than 10%. Even if Europe were going to zero with its emission, the contribution from India just masks anything that Europe can do. You see, if the Indian citizen starts to emit as much as the average world citizen, if the Indian citizen goes from here to here, whatever the Europe does is meaningful. Is meaningless. It counts for nothing. The facts are that the energy needed by the world is 84% from fossil fuels. If you add the nuclear power, becomes almost 90%. If you add the hydropower, and hydropower is a solar energy, is a renewable energy, very good indeed, very powerful as if it is possible, because not every country can have hydropower. For instance, Norway's electricity comes 100% from hydropower. In Sweden, 50% from hydropower, 50% from nuclear power, and so on. But if we put together oil, coal, gas, nuclear, and hydropower, we go to 95%. How these people are dreaming to substitute by operating on this tiny window of solar technology and cover and increase this tiny window covering all this, nobody knows. It's impossible. But it is impossible, especially because it is technically impossible. And there is an interesting reason why it is impossible. I will go with this. This is a typical curve of electricity absorption, for instance, by Italy during the 24 hours in a day. No? There are three curves, one for winter, one for summer, another for the middle season. The fact is that Italy, for instance, has a peak demand at around 7 p.m. At 7 p.m., there is a peak demand. At 7 p.m., it is dark. Solar plants count zero. This is not only Italy. This is United Kingdom. This is United Kingdom. There is a peak high in electricity here at around 7 p.m. And this is California. This is California, October 22, 2016. There is a peak demand in electricity at around 8 p.m. Here, at this time, let's look at this. At this time, solar plants count nothing, and even wind plant could count nothing, because if the wind doesn't blow as we would like, the wind power counts nothing. And indeed, this blue line is the electricity request from California on this day, and the orange line is the electricity given by conventional plants. Coal, gas, nuclear, and so on. The difference is the electricity given by solar and wind. As we see, of course, at 7 p.m. solar does nothing, but indeed on this day, during this night, during all these hours, even wind counted for nothing. So the point is, if we, even though if we were able to shut down all the conventional plant, coal, gas, and nuclear plant, how do we get the energy we need? There is no way to get it. So the conventional plant have to be there, whatever is the amount, the power of the so-called alternative plants, because they count nothing. They count only when they give energy, but they give energy only sometimes. For instance, here on October 26 in California, they gave this energy, the difference between the blue and the yellow. This was given by solar and wind. But it is not sure that this is always possible. So, yes. I think I can stop here because I have a very short time for my talk. But this is what I could say. So there is no way to end up my talk. There is no way. First, that the CO2 reduction will have any success at all. There will be spent a lot of money. Billions of dollars, billions of euros will be spent aiming at this goal. After a few years, European citizen, world citizen could realize that they have spent a lot of money to reach nothing. Thank you.
And thank you, Professor Battaglia. Our next speaker is Angel Cushing. She's a farm leader from Kansas, and her topic is Stop the Green Land Grab, Protect Food Production and People.
My name is Angel Cushing. I live in the Flint Hills of Kansas. Flint Hills is cowboy country. We grow grass here, and that produces wonderful livestock that tastes absolutely wonderful. We are retired military. We retired to this part of Kansas back in 2015, and shortly after there was a planning and zoning regulations that was going into effect that would pretty much eliminate all livestock in this area. They literally zoned everything outside of the city of Emporia as a park. They called it a green space. I got involved at that point. That's been a couple years now, and I've learned an awful lot along the way. We are currently fighting national heritage areas as well as 30 by 30. I could describe all of this really easily in the housing study that I came across through the Flint Hills Regional Council. The housing study actually talked about changing this whole entire area from agriculture and agriculture industry to tourism and energy production. They're planning public use trails along all the major rivers. This is a tourist attraction for everybody to come out to. They are bringing in windmills and solar farms, and they are regulating out agriculture and industry. And when I say they, I mean every federal department that there is. I got to asking that question, who are these people and where did they come from and why are they doing this? And I started with the defining words. For example, in our comprehensive plan here in Lyon County, I kept coming across the term agricultural landscape. And I wanted to know who used this, who defined it, where did this term come from? What I discovered that this term actually comes from an animal rights movement, and it is used by every federal department that there is. Greenscape is another one that's defined by the EPA, and that's literally a park. Everything that is green is considered a park. Open space is wildlife habitat. Riparian areas is wildlife habitat along creeks and rivers. There is no coincidence that we're talking about WOTUS and prairie chicken endangerment and all of those issues, because if you take a look at programs like MAP 21, for example, in the Department of Transportation, it's now been renamed and it's sold as Safe Passages to Schools. But what that is federal money earmarked for the trail system. And that trail system is going to go along rivers and through riparian areas. And how are they going to do that? Well, they're going to probably use WOTUS by expanding that floodplain, in which they will then take that out of production and put in those trails along there. The first thing you have to do is kind of squeeze out agriculture. And here in Lyon County, they did that with regulations. They tried to ban barbed wire and electric fences and all the things that you use to feed cattle. They tried to ban concentrated feeding. I think it was you needed a special use permit if you were to feed 2 or more animals. So that means everybody, even the recreational horse owner, would have to get a special use permit in order to set a round hay bale out for their livestock. That's basically asking permission to take care of your own farm animals. I got interested in that subject, and we discovered that there's a national heritage area already in Kansas, and there's another one going in north central Kansas and south central Nebraska. And that was a proposal. And we started informing people of this national heritage area. It's all the same line. It's the, this time though, it's in the name of preservation, in the name of recreation. But it's still the same thing, still coveting land, still pulling out agriculture, and still replacing that with tourism and energy production. And we started fighting that, and we started informing the public, and we started conducting meetings, and we had anywhere from 300 to 500 people that came to these meetings, and they started asking their county commissioners to pass resolutions against them. Now, the National Park Service requires that before a national heritage area goes in, it has to have the approval of the people that these areas would be affected. We've discovered that there are 55 national heritage areas in the country. None of them, nobody knew they were going in until after the fact. And that's pretty significant because these are federal boundaries that are voted on by Congress. That's a boundary map that they are implementing over private property without anybody knowing about it. On the bottom end, it's a fundraiser for special interest groups. On the top end, it's all about preservation through land management. And it just depends on each national heritage area as to how they're going in. We have gotten 38 counties to pass resolutions against the Kansas-Nebraska Heritage Area Partnership, and that's out of 49. And we now have one county down in Freedom's Frontier National Heritage Area of Kansas that has passed a resolution to get out of Freedom's Frontier National Heritage Area. That's significant, as 30 of these 55 national heritage areas are in front of Congress this year. They are required by law to be self-sustaining within 15 years. Not one is, not one. Naturally, they have to go back in front of Congress and beg for more money. So if there are people in these national heritage areas that want out of these 30 national heritage areas, now is the time, while it's going through Congress, to start making that demand. We get asked a lot how this ties into 30 by 30. Well, there's a couple of ways. One is that we know that there's been land grabbing going on for quite some time. And for the first time in history, a president put it in black and white and confessed to it. And I think that has emboldened those that are in the business of preservation for recreation and those who want to covet land, that they can continue on and go on. And they're probably right. If this proposal, even with the 38 counties that are clearly against this, if this were to go in front of Congress, it would probably get passed because it can and because it would be attached to the other 30. They won't back off, we think, because of that 30 by 30 program. The other aspect is conservation easements. We discover wherever these are going in, a lot of the money goes to other special interest groups who then use that to purchase personal property rights. Conservation easements is a big component of this. The Historical Preservation Act of 1966 is as well, along with the Antiquities Act of 1906. And that is the one that scares me the most. If you take the 30 by 30 plan and you realize that this is how we got the monuments and the national parks out west that we have, and now you've just created a federal border that creates jurisdiction under the Antiquities Act, it's just ripe. It's just ripe and ready for a president and the right administration to come along and declare that land as a national park. We keep getting told how inspiring we are and how much we're making a difference and encouraged a lot, but in all honesty, it feels like I'm losing this battle. Feels like nobody's hearing. The federal level where these decisions are being made isn't listening. Half of the people, as much as they think that we're inspiring, they don't realize what's at stake, that the choice of what they have on their own dinner plate is at stake here. That's very scary. So while we try to be inspiring as much as possible, at the same time, I feel like that I need to warn everybody that if they're not paying attention, if they're not getting to know who their congressmen are, they're not getting to know who their county commissioners are, they could have their choices limited drastically. Lyon County is a perfect example of that. Sadly, we are not the only one. The method in which this is done is called a joint comprehensive plan and zoning regulations. What that does is combine the city with the rural areas. You usually have more city supervisors or more city commissioners than you do in the county. So once this deal is set and made, that's it, it's done. The city now outvotes the county. They're now going to have more representation and they're going to vote to trail on your land and fish out of your cattle pond. It's recreation to them, so they'll vote in that favor. So it's really hard to undo these programs once they come in. How they're getting in is through grant money. They are waiving lots of dollars in front of city commissioners or county commissioners and say, all you got to do is update your plans in order to obtain grant money. We can help you find a contractor that will rewrite your planning and zoning for you. In our case, it's Urban Collaborative out of Portland, Oregon. They are cricket farmers. Literally on their website, they had this big thing about how livestock are ruining the earth and the protein of the future is bugs with a adorable little girl shoving crickets into her mouth. These are the people that wrote our comprehensive planning and zoning regulations for us. They were compensated for that again through a grant from the HUD. from housing and urban development. And it was just walked through kind of under the table. They did the minimum notification necessary to meet Kansas law, but kind of under the table. They really didn't invite too many people, and they weren't really on the up and up about what exactly they were doing. I actually went to one of these meetings at one time. They did not say, we're rewriting your comprehensive planning and zoning. They said, we're here to find out, to do a survey just to find out what your needs are. So it's all on the, it's all on the down low, very, very shady that they're coming in using regulations. That's the first step, I think, is regulations. Once you start regulating people out, and a lot of people might not even realize that they're being regulated out. A good example of that is sitting at a picnic table. A lady asked me over listening to, she was overhearing our conversation, and she asked me if this had anything to do with the shingles on her roof. When I inquired further, she explained to me that she is up in Johnson County. For those that don't know, that's the Kansas City area. She said that she needed new shingles on her roof, and she opened the phone book. She called roofers. They told her that she first needed to go down and get a permit. She went down and she got a permit, and the clerk or the folks at the permit office asked her what kind of shingles is she using, and she said, I don't know. I guess we have to discuss that with the roofer. And they pulled out a board with shingle samples, and they said, you have to pick one of these. And that's how drastic this comes to. Turns out that they do have a joint comprehensive plan over them. They do have these regulations. I would describe them as a homeowners association from, from a very dark place, very controlling. And it controls all the way down to what products that you're going to be able to shingle your own roof with. And it's all about protecting the view shed. And the view shed is best described by what would you see if you were driving down a New England road from your car. Pastel color houses with shutters and pretty shingles and just the picture perfect world. And they paint this as the optimum place that we should be here in the Midwest. We get asked a lot, especially by the old timers, if this has anything to do with Buffalo Commons. I'm young enough that I actually had to look that up and Google that word, that phrase. And my answer would be, though I found no evidence that says that this is Buffalo Commons, I have found no evidence that says this is not Buffalo Commons. What Buffalo Commons is an older version of 30 by 30. It's to depopulate these plain states and turn this into a national park area.
Great. Well, thank you very much, Angel. And I don't think you're losing the fight if we do what we have to do. There's a couple things I'd like to just take a minute to point out to people. One is in the description. If you're watching on YouTube, in the description below the video is a link where you can join the Schiller Institute. And I would urge everybody watching to make sure that you are a member of the Schiller Institute. You can contribute on nearly any level, monthly, one time. It helps us to be able to do this work internationally. I also wanted to encourage people who are watching on YouTube to like this video and share this video. I think you can see by what's been presented already, and we have more to come, that this will be a very powerful organizing tool for all of the reality deniers. So with that, I would like to introduce our next speaker, who is Christian Lonemeyer from Germany. He is a farm leader. He's also a board member of the Landvolk Mittelweser of Lower Saxony. And what we're going to be seeing from him is a video report filmed near the Weser River on July 15th. And the topic is flooding disaster is not caused by climate. It's immoral negligence.
Just a while ago, I got a call from a completely upset farm leader, Marcus Wipperfurt, who gave a stunned report on the situation on the ground in are viler. Right now, about 50 farmers there are trying to somehow get a grip on the war-type conditions they are facing. These farmers are not supported by anyone. There is no fire department. There is no disaster relief agency, no military personnel, not even an official contact person. These farmers are putting their lives in danger. Bridges are no longer safe. Roads have been washed out. Horses threaten to collapse. Electricity and gas lines are dangerous. When you lift a tree log or a pile, you never know what you're going to find underneath and how to deal with it. There's no coordination of the efforts there. They've all been pretty much left on their own. And all this is happening in 2021 after one of the most severe weather disasters that had a 3-day lead time. For 3 days, meteorologists, one after the other, have been predicting catastrophic rainfall almost in unison. And we farmers have been asking ourselves for 5 days, why are they not evacuating the campgrounds? Why not actively intervening? People were there confirmed they had not been warned. There was no sirens, no warnings, nothing in the evening after it had rained. I myself watched TV, the major stations, to see if there was any special broadcast, any reactions to what was going on. Nothing. Nothing at all. And then there was politicians, these media, dare to stand in front of the cameras and blame climate change for the situation. What does climate change have to do with the fact that the catastrophic has been building up for the region in 3 days? It's been well known for the approaching, but nobody warned and nobody reached out. That was nothing to do with climate change, but everything to do with the failure of political leaders and public TV channels when nothing is happening there. And then a certain Werner Eckert of the TV, who heads the environmental department there, sits there and is allowed to spout comments of the daily news. He said there's been asked why he didn't warn people via the TV. Many would still be alive today if those who perished. That is the truth. And we could have prevented a lot of damage by evacuating the animals in time and getting the campers' cars and leave. There would have been time enough. Nobody reacted. We farmers, we're blamed for everything. We're constantly killing people with our activity, they say. But when they do something wrong, when they fail to act, by basically ignoring one of the biggest storm disasters, which has been announced for 3 days, then something else is to blame. Climate change, or the vacation season, or something else. We're all supposed to cope with climate change. How can we accept such a segment as an excuse? So many situations and authorities are like having completely failed. They slept for days, and people have died because of that. And now the volunteer helpers come and are left in their own devices because nobody has the balls to coordinate things in a reasonable way. I've never seen a farm leader, Marcus Vipperfirk, in such a state. And believe me, if you also go there and help, you will never have seen such a situation. That these people have left alone and helpless, that they don't receive support immediately, is just one of the scandals and a further failure by those who have constantly telling us what to do and how to do it correctly, but who don't even know the basics of how to assume their own responsibilities.
Thank you very much, Mr. Lonemeyer. And I want to say that the passion with which he expressed what he had to say is exactly what needs to be expressed about the real story of what the cost of these sorts of ideas is for real human beings in real circumstances. We're going to be talking here, or hearing it rather, from Paul Driessen. He's well known to many, but others don't know him. He is the author of Eco-Imperialism, Green Power, Black Death, and his topic is Extreme Weather Events, Myth and Reality.
Recent disastrous and deadly floods in Germany and other parts of Europe have put climate change back in the news, with government officials once again blaming fossil fuel emissions for the calamity to deflect attention from their official incompetence. These officials are blaming the very fossil fuels that power Europe's economy and power the very boats, ambulances, and other equipment that were used to rescue people, recover bodies, and nurse people back to health. These same officials could and should have prepared their communities for floods like those that come to Germany and other parts of Europe every few decades, but they failed to do so. These very same officials were warned days in advance that these rains and floods were coming. They were told almost exactly where and when the rains and floods would hit. The very same officials had a duty to warn people and get them out of harm's way. But these officials failed to warn their citizens that they, their homes, and their children were about to be swept away by raging flood waters if they didn't evacuate immediately. It's no wonder they want to blame man-made climate change. They try to blame man-made climate change for almost every extreme weather event these days because they and their allies have major political and financial stakes in this blame game. They also drive their anti-fossil fuel agenda by lying, obfuscating, removing or altering charts and historical data, and trying to confuse people by conflating tornado sightings last year with historic records of violent, devastating twisters that, as I said, come every few years or decades. Let's take a look at a few climate and weather realities and historical data, just to put all of this in context and keep you from being bamboozled by more climate lies in the future. Floods, for example, are not uncommon. They're not unprecedented. They're not nice to people or civilization or nature. Heavy rains and floods occur with quite some regularity, actually, and they can be totally devastating. I was in Florence, Italy, just 3 years after the Great Arno River flood of 1966. I was in Prague, Czech Republic, not long after the extreme Vltava River floods of 2002 and 2013. I saw the high water marks that were left on buildings way over my head and some 30 to 50 feet above normal river levels. Floods happen. And the more concrete and asphalt we put in our cities, the less regular natural drainage we have, and the more flooding we get. Not just in Florence or Prague or Germany, but in Houston and everywhere. What caused those floods back in 1966 and 2002? Or the Prague flood of 1890? The awful German floods of 1790 and 1910? The Johnstown, Pennsylvania flood of 1889? What about the deadly Big Thompson flood of 1976? I was actually in the canyon a week after that flood, and the death and destruction were just absolutely incredible. All those floods were natural, but today's somehow are man-made. As Mr. Biden likes to say, come on, man, give me a break. Hurricanes are also common, recurring, devastating, and deadly. It's fashionable today to blame Harvey and Irma and every other hurricane on fossil fuels, carbon dioxide, and us humans. But it's a lie. Between Wilma in 2005 and Harvey in 2017, the United States enjoyed a 12-year major hurricane drought. That's 12 years without one category 3 to 5 hurricane making U.S. landfall. It was the longest period in history that America was not hammered by a major 3 to 5 category hurricane. If we're going to blame every modern era hurricane on fossil fuel emissions, don't we also have to thank fossil fuel emissions for that wonderful 12-year hiatus or absence of deadly hurricanes that we enjoyed between 2005 and 2017? Probably not. It just doesn't work that way. But let's at least be honest and consistent. Accept that hurricanes will always be with us and prepare better for them. Yes, U.S. property damage and raw dollars from hurricanes is way up, but that's because we have far more people building far more expensive homes right in the path of hurricanes along our coasts, where hurricanes do strike with regularity and intensity. Thankfully, though, death tolls are way down because buildings are built better and people get warned far enough in advance to get out of the way, to evacuate areas where the hurricane is going to strike hardest. In other positive news, global death tolls and property damage from all weather-related disasters as a proportion of global domestic product have gone down significantly between 1990 and today, pretty much for the same reasons as you can see in this chart. Tornadoes as well. This chart from the Washington Post just a couple years ago makes it clear as a sunny day that violent F4 and F5 tornadoes have been much less frequent over the past 35 years than they were during the 35-year period before that, 1950 to 1985. And even more amazing, for the first time in history, the United States was not hit by a single violent F4 to F5 twister in all of 2018. Was that also because of fossil fuel emissions? Very few tornadoes that we've witnessed in recent years or decades compare to the horrific Gainesville, Georgia tornado of 1936, which killed 450 people. Or the even more horrendous, record-setting tri-state twister of 1925. That one was a mile wide. It lasted 3.5 hours and went 220 miles across 3 states, obliterated entire towns, and killed over 700 people. That was just a monumental U.S. disaster, never equaled since. Freak blizzards, equally predictable. Almost every time there's a big blizzard nowadays, we're told it's because of carbon emissions, and we can expect more of them as well in the future. The same con artists want us to forget the Nebraska school children's blizzard of January 1888, when a relatively warm day with snow melting all around people was suddenly transformed into a nasty, deadly winter storm. In less than 3 hours, temperatures plummeted from plus 35 to minus 20, and in many places even minus 40. Winds howled down from the north, bringing many feet of snow. The storm killed almost 500 people in several states, but most of them in Nebraska. Many were children trying to escape and get home from their frozen, battered schoolhouses that the winds had blown the roofs from. And parents were out looking for their children and froze to death. That blizzard made U.S. and international news. But within just a couple months, it was overshadowed and largely forgotten by the great mid-Atlantic blizzard of March 1888. That one buried New York City and much of the entire East Coast up into Canada under mountains of snow. And dozens of New Yorkers were not found until days later, when their frozen bodies were dug out from massive snowdrifts. Back then, people learned from these vicious blizzards. Midwesterners invested in stronger homes and schools, in better weather forecasting. They also made sure they kept winter clothing with them and their kids, even when the weather looked balmy and nobody was expecting a blizzard. New York City used that storm to drive the efforts to build its famous subway system so that in the future, people could travel safely and out of harm's way underground, away from the snows and winds and cold. Today, Mayor de Blasio, Governor Cuomo, and their allies just blame man-made climate change for just about every disaster. They abdicate their own roles in the floods, property damage, and death from natural disasters like Superstorm Sandy. In that storm, they simply failed to warn their people what was actually coming, and they did not prepare in any reasonable way for the death and destruction that were to come. They somehow think they can control the climate and weather, or at least They're sure they can get richer and more powerful trying to do so at our expense. So don't get bamboozled by lying, obfuscating con artists and climate alarmists, who for their own ignorant or selfish reasons claim we can just get rid of the fossil fuels that provide 80% of America's and the world's energy, and then somehow magically replace those fuels with land-intensive, raw materials-hungry, expensive, intermittent, unreliable, weather-dependent wind and solar power. If you let yourselves get conned on that one, your jobs will disappear, your living standards will plummet, your lives will be at much greater risk, your energy prices will skyrocket, your environment will be destroyed. And you'll probably deserve what you get. Thank you.
Thank you, Paul Dreesen. We are now going to go, and just to leave time for questions, you may notice some of the presentations are slightly clipped. They will be available in full on the website later. We're going to hear from Professor Emeritus Alwin Burgholte, who is from the Wilhelmshaven University of Applied Sciences. His topic is how future electricity security is threatened by wind and solar technology and blackouts.
Will electricity supply security be threatened in the future by wind, solar, and blackouts? The electric power supply requires indispensable prerequisites. The generating capacity must always correspond exactly to the required power or the consumer electricity. Power is measured in kilowatts, megawatts, or gigawatts. The power demand in the Federal Republic of Germany varies between 40 gigawatt and 80 gigawatt, depending on the time of year and day. The energy demand is the result of the product performance times time and is measured in kilowatt hours, megawatt hours, gigawatt hours, or terawatt hours. The annual electricity energy demand of Germany is about 600 terawatt hours. The distribution of the electrical power occurs with a constant frequency of 50 Hz with different voltages. Low voltage 230 to 400 volts or for domestic use, and medium voltage 10 kilovolt, 20 kilovolt or 30 kilovolt for regional distribution. High and extra high voltages, 110 kilovolt, 220 kilovolt or 380 kilovolt, are used for large power consumers and the long distance distribution. Only powerful power plants, the so-called baseload power plants, can provide and guarantee a constant frequency. A constant grid frequency is of utmost importance for most consumers. Conventional power plants determine the grid frequency via their constant rotational speed. When the load on the grid is high, the rotational frequency drops, and with it the frequency. This is like riding a bicycle. Uphill, you slow down. Wind and solar plants can only generate electrical power depending on the weather. They are also not able to build up their own 50 Hz grid. Without an existing stable power grid, the installations can neither be started up nor controlled or monitored. On the basis of the bill for the promotion of regenerative energies, however, in Germany the power generated by these plants is always purchased on a preferential basis at a fixed guaranteed price for 20 years per kilowatt hour. Power that is generated but not used is sold at low prices on the European markets or given away, and in some cases even at negative electricity prices. In order to maintain grid stability, a minimum power share of 25 to 35% of the consumption must always be fed into the grid by the 50 Hz power plants. The renewable energy shares mentioned say absolutely nothing about the percentage of available power. As said, conventional power plants currently guarantee the secured power supply. The Federal Network Agency, Bundesnetzagentur, is responsible for monitoring the security of electrical supply in Germany. It decides whether and where power plants may be shut down. The contribution of wind power plants to the secure power supply is classified by the Federal Network Agency as 1% and that of solar plants only with 0%. There is a lack of long-term storage to bridge the feed-in gaps. The German grid has also experienced power shortages on several occasions with the threat of a blackout. What are the causes of grid disturbances and how is a blackout defined? We are talking today about a blackout when the power supply fails over a large area for more than 8 hours. And when the reconstruction of the electrical power supply requires a coordinated formation of sub-networks and the decentralized deployment of suitable power plants. The reconstruction of the grid can take weeks in the event of a large-scale outage. Short-term power outages, which are regionally limited, occur more frequently and can also be remedied at short notice. Natural causes can be responsible for an outage, such as storms, floods, snow and ice loads. If a power supply cable is destroyed during construction work, there's also a power failure. Short circuits to ground or between phases also interrupt the electrical power supply. More dangerous, however, can be electromagnetic pulses, EMP, a brief broadband electromagnetic radiation that is emitted during a one-time high-energy balancing process. For example, lightning causes massive electromagnetic interference, especially along the lightning path and on the point of impact. The electromagnetic pulse is also called lightning electromagnetic pulse, LEMP. A nuclear electromagnetic pulse, in short NEMP, is generated by the explosion of a nuclear weapon at an altitude of several hundred kilometers. The gamma radiation generated in this way has an immediate effect on electronic systems, so that they can be disrupted or completely destroyed. Is the probability of blackouts increasing? Does the turnaround in energy policy, the conversion of the electricity supply to exclusively regenerative generation sources, have an influence on this? Many experts and responsible persons consider this to be very low. They argue that everything remains technically controllable. Sometimes there is less wind or there are fewer hours of sunshine, then more power has to be imported. For this, the transmission networks must be expanded more. Shortage of renewable energy, however, is occurring over a large area of Europe. This means that it will often not be possible to import the missing power from neighboring countries. On Friday, January 8, 2021, at 2:04 p.m., a serious incident occurred in the European power system, the largest interconnected power grid in the world. The incident resulted in a grid disconnection. The failure of a power plant in Croatia resulted in an overload of 13 other nodes in southeastern Europe. With 49.8 Hz, the frequency fell below the lower disconnection limit. This frequency drop, which was low from 50 Hz, thus led to a splitting of the network. For the self-protection of the other networks, the entire Balkan region and Turkey were separated from the European network. This grid separation was remedied after about 1 hour by activating reserve power plants by the European transmission system operators. The problem lies in the absolute requirement that electricity production must at all times exactly match the electricity consumption. If a gap occurs in this process, a blackout can result. In 2003, for example, there was a major blackout in the US. A defect in a power station in New York caused chaos in northeastern America and in parts of Canada. Tens of thousands of people were stuck in traffic jams. All traffic lights were out. Many people were stuck in elevators. Subways and trains were stuck, and the telephone network only worked partially. In the UN building, thousands of employees had to be sent home. The stock market on Wall Street was also affected. On November 4th, 2006, the lights went out in large parts of Europe due to human error. Without coordination and communication, a high voltage line in Lower Saxony was switched off for the departure of a cruise ship. In a chain reaction, several lines went off the grid. About 15 million people in Germany, France, Belgium, Italy, Austria and Spain were without electrical power for up to 2 hours. In the German grid, electricity became scarce on June 6, 12 and 25 in 2019. The situation in the power grid was critical. The reason were speculative manipulations on higher prices for reserve power. There are also stability problems in the German grid almost every 15 minutes because new electricity prices are published on the electricity exchange every 15 minutes, and this leads to grid switching among consumers.
We want to thank Professor Burgholte for his presentation. We are cutting it a bit just because we have to get to the discussion. That we're getting a lot of questions, and we want to stay on schedule. The full presentation will be available up at the Schiller site. We're now going to conclude the panel by returning to the Schiller Institute's Jason Ross for summary remarks, and we will follow that with discussion. And if you've just joined us, you're viewing the Schiller Institute's special conference, There Is No Climate Emergency, Apply the Science and Economics of Development to Stop Blackouts and Death. And of course, we're asking everyone to subscribe to the Schiller Institute and become members of the Schiller Institute as well. And so we'll go right back now to Jason, who will do some final remarks, and we'll go to the discussion. Jason?
Okay, thanks, Dennis. So this has been a really, I think, very powerful panel. What we've heard so far, being able to go through, well, I don't need to repeat it. We heard it. It was very, very effective. The idea of what we should be doing, I think, needs some more, would benefit from additional discussion on that. Let's put it that way. So one of the aspects, one of the ideas that's presented is that there are limits to growth. Let's just take a look at that one very simply. And let's talk about what kind of things would be limited for human beings. You know, we hear that there are limited resources, for example. But the thing is that human beings don't really, we do consume resources, but unlike animals, we create resources. That's the most characteristic thing about our activity. What do we create? So coal, for example, it's a resource in a certain way for, you know, burning in a fireplace or being more compact than wood and making, you know, it being convenient in that way. But it was the development of the steam-powered engine, this technology, this scientific concept that turned coal into an extremely powerful, world-changing, civilization-shaping resource. We made that resource. We allowed coal to become a resource in that way. Uranium, a very powerful resource, enormous amounts of energy, you know, a whole lifetime supply of energy in the palm of your hand in terms of uranium nuclear fuel for nuclear power. That certainly wasn't a resource for anything except being a yellow mineral that you could use for, you know, for its color or for staining glass. That's all people did with it before the development of nuclear science. So we do not need to worry about limited resources in the sense that we're going to rely either on those resources exclusively for the future or based on our current methods of achieving or of gathering those resources. We've seen enormous advances, for example, in the technology for coal mining. making it much, much, much safer, much, much cleaner. Coal plants are effectively as clean in terms of their emissions as a natural gas plant nowadays, modern coal plants. So we do this. We create these resources. And the greatest resource of all, naturally, is not coal, it's not uranium. It is the human mind. And what this means is, what kind of cultural investment are we making into our society in the form of science drivers, technology initiatives, and also in terms of our culture, our education? What are our schools like? What kind of future are we creating? And do we have in mind when we make these kinds of policies? So to achieve that ultimate resource, the powers of the mind, the ability to do good, to come to know better how the universe works, and use that knowledge to improve the potential lives of everybody on the planet, that's the greatest good that any human being can do. That is our truest self-interest. It's in that way that we are said to be made in the image of God. This is a very powerful concept that was key in the Renaissance, that our minds were in the image of the Creator in such a way that we can actually figure out how the universe really works and then use that knowledge. That is a powerful concept. It's not self-evident, I wouldn't say, and it's a very powerful one. I think it's true. So in order to best exercise those powers of the mind to adopt missions that are really going to advance us, one of the things that absolutely has to be included is space. And space was a very major focus during Lyndon LaRouche's political work. In the 1980s, he had produced a video, The Woman on Mars, as well as a whole outlook, a whole program about the science and technology needed to colonize Mars, where he talked about what would be required to set up a Mars city, not for, rich tourists to go to, not for Jeff Bezos to go up and to almost go up into space for a little vacation, but to set up a scientific city. I'd said at the beginning how the far side of the moon is a great place for radio astronomy. Setting up an astronomical telescope, so to speak, with an artificial aperture the size of Mars's orbit. And this is going to be absolutely transformative in how we're able to understand the whole universe and discover new principles, and who knows what applications those will have here. We're going to have a powerful cultural impact in just learning and being committed to discovery and doing enormous things, and also the very practical, you might say physical benefits of discovering new principles and being able to use them. So, what is the mission, taking it to the United States right now, what's the mission of the United States? To maintain world supremacy, to ensure that China never becomes more powerful according to certain categories than the United States. What kind of mission is that? What are you actually doing? Not what is your standing. What are you actually doing? Right? We've left Afghanistan. This is the subject for our event next weekend. But as with the military pullout of Afghanistan, okay, will there be an engineering influx? What can the United States contribute to the world in the fields of science, of engineering, of infrastructure development, and be able to play a positive role in ending poverty completely on this planet, in developing higher forms of infrastructure, new infrastructure platforms that are going to be able to support a level of productivity that within a couple of generations should be 10 times what we're capable of right now. That's an actual mission. So I'm going to just a bit more about nuclear power and about the green movement and cultural optimism. So in terms of why nuclear power is so great, let's look at it in the context of some economic indicators that Lyndon LaRouche identified for gauging the development of an economy. He looked at things like an increasing use of energy overall. More energy use per person, more energy use per land area. If you look at a chart, which I'm not going to show right now, but you pull up a chart of energy use compared to lifespan, it's obvious. You pull up a chart of the infrastructure density versus lifespan or health in countries around the world, it's very obvious that energy use, infrastructure density, this is key. The other thing that's key is increasing the intensity of your energy sources. And this is sort of the reason that trying to use wind or solar power, which are so incredibly, they're not concentrated at all. They're very diffuse forms of power. Why these things are so unreliable, they're intermittent, and they're also extremely expensive in physical terms. The amount of material that goes into creating solar panels to produce a certain amount of energy, when you get it, it's more than 100 times the amount of material that goes into drawing power from uranium that goes into creating a nuclear plant. The land use, similarly, 100 times greater for trying to use solar power than to use a nuclear plant. Enormous waste of space, enormous waste of materials, extremely expensive materials. And the idea that these things are renewable. I mean, the sun rises every day, the wind blows. Windmills aren't renewable. They get old. They fall apart. They don't renew. A new one doesn't grow next to it like a bulb, planted in the ground or something. Same with solar panels. They're expensive. They're physically useless because they're extremely low density. So why is nuclear power so great? Fundamentally, there's a different kind of physical process involved in nuclear reactions compared to chemical reactions. So if you burn coal, that's a chemical reaction. Coal is combining with oxygen, it's forming water, carbon dioxide, some other things. Natural gas, you're combining methane with oxygen, you're burning it, you're producing water, carbon dioxide, and a little bit of other stuff. Those chemical transformations they hold a lot more power than a physical source like wind blowing or water running through a water wheel. And the amount of water required to make power with hydroelectricity is orders of magnitude more than the amount of petroleum required to make that same amount of energy. When we move to nuclear, the increase is 1 million times. The nuclear bonds that hold the nucleus together, when we start acting on that level, this incredibly small level, we're looking down at very, very, very small, the amount of power is increasing in an enormous way. And nuclear transformation, 1 million times more powerful than a chemical transformation, speaking very rough terms. This is why you can hold your lifetime supply of uranium in your hand. The great thing about nuclear waste, there's barely any of it. There's barely any of it. And we already know what to do with it. It's very safe. So in terms of the world direction that we've got this great reset, push for a banker's dictatorship. We've got the Green New Deal as a way to enforce and urge people to love low living standards, both for themselves and for the people around the world whose development they play a role in preventing by saying that carbon dioxide must be cut at all costs, including human costs, even though supposedly we're doing this for the future of, humanity. And there's, in all of this, a deliberately created cultural despair that we live in. The ugliness, the stupidity, the anti-human religious-like fervor that animates too many people, part of the green movement, this didn't come out of nowhere. This has been deliberately created. It is not sort of naturally flourishing, and it can be overcome and replaced with something far better. In the aftermath of World War II, the Congress of Cultural Freedom helped promote the kind of garbage that gets called art or modern art, which, children are honest about and say there's nothing there. Whereas other people say, yes, I will buy that from Hunter Biden. The cultural outlook that can replace all of this is one of creativity, it's one of development, and embarking on national missions for achieving breakthroughs in nuclear fusion, for revitalizing our space program, going back to the moon, not just to visit for a little bit, but to set up a base, right? To set up a permanent settlement there, including the industrialization of the moon, using resources there directly for production of things that we'll use on the moon, and then also eventually for production of assets that we're going to be using in space more broadly. And what's going to come out of all of this? One is a very huge and direct economic benefit that we get, similar to what we achieved in going to the moon in the 1960s, where we got a 10-to-1 at least payback. Well, really, it's an uncountable payback, but a 10-to-1 payback, even looking at sort of dollars just over the decade after going to the moon in terms of economic growth. We had a huge cultural sense that if we can go to the moon, why can't we fill in the blank? And what we get out of it is this broader mission is nuclear power developed in part for nuclear rockets to be able to take care of real climate emergencies like an asteroid striking the Earth, which is going to be a far bigger deal than a potential rise in temperature of a degree and a half over 100 years. So I think that we can be very excited about what we can do as human beings and be very bold in mocking, ridiculing, poking holes in, helping people simply to question this prevailing dogma about a green religious outlook in which our activities are inherently sinful and wicked, that nature is supreme, that we shouldn't go around changing it, and if we do, nature will get very angry with us, and therefore we'll have to throw our future away in order to appease nature, to have some hope of surviving over decades to come. It's just not a real threat. Real threats to people come from underdevelopment, not a small change in the temperature. Is somebody going to die because the temperature increases by a degree over a century? Or are people going to die because the power goes out in a blackout and their heating shuts down and they freeze to death? So let's keep our eyes on the prize here and move towards increasing levels of energy use, energy density. Energy is good. Using more of it, that is a good thing, not a bad thing.
All right. Thank you very much, Jason. So what we're going to do now is bring up our discussants. And as we do that, let me simply indicate for people that would have gotten on and during the course of the proceedings, our second panel, which will be beginning at 2 p.m. for our conference. We've now concluded the first panel of our conference, There is no Climate Emergency, Applying the Science and Economics of Development to Stop Blackouts and Death. Panel 2 is called Energy, World Health, and the End of War, the Power of Energy Flux Density. And the purpose of that panel is to talk about the alternatives and how those alternatives can be implemented. It will be keynoted by Helga Zepp-LaRouche, the founder and president of the Schiller Institute, and we again will be starting at 2 p.m. So now what we're going to do is bring up our discussants, and we've got Diane Sayers there, who's our co-host for today, and Jason, and I see the professor, Francesco Battaglia, is with us. Welcome, Prof. And I think we're going to go to you pretty soon. I know we were getting questions. Apparently, Diane tells me or wrote to me that there are a lot of them. So, Diane, why don't we go right to you?
Okay, I'm going to group two of these together, and perhaps both Jason and the professor want to take them, and then I have one specifically for Professor Battaglia later. Someone writes, is it true that the rainforests of Brazil and Gabon are the, quote, lungs of the world, moderate temperature worldwide, and should never be touched or developed? That's the first question, and I think related. We are told that agricultural expansion, wood harvesting for charcoal, and infrastructure building exacerbate the problem of deforestation. My question is, since carbon dioxide is needed by trees and plants as a source of food, doesn't it make logical sense to increase and not decrease CO2 content in the atmosphere to provide more nutrition and speed up the reforestation? The two related questions. Maybe, Jason, do you want to start, and then the professor?
Sure. Yeah, I'll start. So, is the Amazon, is Gabon, is this the lungs of the world? I remember this happened a few years ago with some fires that took place in Brazil, and we heard people say this. It doesn't really make any sense. I mean, there is forests do create oxygen, but they also use oxygen. I mean, if every year the forest was taking in more and more carbon dioxide and then it never left the forest, it would have to start becoming a growing mass or a mountain of, carbon, charcoal. But the mass of the forest doesn't just increase forever. I mean, a stable forest is, their ecosystem is stable. They're not as a net sucking carbon dioxide out of the atmosphere. It's just not true, and pretty obviously not true. As far as whether these regions should be protected or developed, one of the first thing I got to say is that you can't, when you get into sort of telling countries you can't develop or you better not develop, that is imperialism. It is not right, and it is a way of saying we're going to tell you that you cannot develop. And you got to be real careful with that. Second thing is there is an awful lot of interesting life there, and it would make sense to be able to study, this life and this sort of thing. So there's something to, maintaining these kinds of environments for study and to learn more about them. But one of the greatest ways that you can protect forests against one of their least useful purposes. Sometimes, a forest is cleared for people to have a place to live or to grow crops. Okay. Sometimes wood is harvested simply to burn as wood. That is really, really stupid and inefficient. So the development of a power grid, the development of an infrastructure network that can supply power in the form of electricity, which is far more effective than burning wood, that will do more to preserve forests than I think an awful lot of environmental regulations that could be directly tried to be applied to that. It's just sort of a natural thing. You don't burn wood if you have something better. On the deforestation and CO2, yes, more CO2 in the atmosphere does help plants grow better. That's part of the reason that there has been a greening of the earth in the recent decades. I don't think we should try to increase CO2 on purpose, in part because some of these power sources simply are properly replaced with nuclear energy, especially as we develop better and better forms of nuclear power and nuclear fusion. It simply may make very little sense to keep burning coal, certainly burning petroleum. Petroleum we can use as a raw material, right? We make plastics, we make materials out of petroleum. So burning it, I think in the future will seem as foolish as burning trees was, or backwards as burning trees would seem today. But we should not worry about CO2 emissions and take actions that will dramatically reduce living conditions now and into the future in an effort to prevent CO2 levels from rising. It would defeat even the stated purpose, which is to help make the future better. Well, if you're causing poverty right now, really, what good are you doing?
Okay, Professor Battaglia? I think you're muted.
Okay, you listen to me now?
Yes, got you.
Okay. Yes, thank you. I think we should not even talk about CO2. CO2 is not a problem. It's just like talking about water. Why should we worry about water more than CO2 or about CO2 more than water? The real issue here is that humanity needs energy. This is very, very important. If we don't want to die, if we don't want to go back to slavery, humanity needs energy. We should realize that solar energy, sun energy, is the energy of the past. Until about 200 years ago, the energy that humans were using was 100% sun energy. Now, sun energy provides 10%. So sun energy is the energy of the past. So the CO2 is not a word that we should even mention. We should not talk about CO2. We should talk about energy. And the future of energy is definitely nuclear power, at least as far as electricity production concerns.
Succinct and to the point. Okay, so you had another question for the professor, Diane?
Yes, this one, I hope you can resolve this paradox. The person writes, I'm hoping you can resolve one seeming contradiction. I've seen other reports that the sun is in a quiescent phase, but temperatures don't seem to be falling. And the most important evidence of temperature rise is the melting of the polar ice, and to a lesser extent, the melting of Antarctic ice. If the sun is in a low phase, as the senator showed, why are we still seeing what appears to be an alarming melt, especially in Greenland and the Arctic?
I don't know whether there is an alarming melt. First of all, melting ice, obviously if temperature goes up, obviously some ice will melt. That's for sure. The point is whether you as humans, with our activities are the causes of this increased temperature. But there is nothing to be alarmed actually about, because as I have shown in my talk, the ice, for instance, in the Alps was much lower in the past than now. This is very clear. So what we are worried about today has already happened in the past, even with stronger intensity. And nothing bad has happened in the past. Why should we worry about what is going on today?
Great.
Okay, fine. At this point, let me just ask a question here. Diane, you have several other questions on your end too, right? Because I have various. Okay. Why don't you do one, because I'm going to bring up a student in just a minute, and we've got to make a little technical change here. So why don't you do the next question?
Okay. Yeah, I'll read this one. This is directed to Angel, but I think it's related to several questions that have come in about, particularly on the YouTube chat, where people are getting very alarmed about the restrictions in building things. I know Helga has talked to us about various restrictions in Europe where you're not oddly enough, we're not supposed to use steel and concrete. We're supposed to use bamboo or wood or something. So people are asking questions about these kind of restrictions. Is everyone going to be restricted in how they are allowed to build even their own house, etc.? They're asking explicitly in New York, but I think this is actually in the North America and Europe as well. So perhaps both of you could address that.
I didn't understand what kind of restrictions. Who restricts what?
That you are not allowed to use certain materials. Like they say steel is too damaging to the environment, so you have to use plastic or something like that.
What's wrong with plastic? It's a very good material. It's an excellent material. But I don't see why. I mean, it seems that
they're actually wood. They're actually proposing wood. They're proposing wood to replace steel.
There's sort of the ironies that I own with some of this.
Go ahead, Jason. Maybe.
Well, I mean, a couple of the restrictions I know about or that I've seen here in the U.S. has been some places like San Francisco are saying that if you're building a new apartment or a new home, you can't use gas, no natural gas. So you can't have a gas water heater, you can't have gas heating, you can't have a gas, range for your cooking, right? And this obviously hasn't, gone down very well. People have been very upset about this. Or in England, they tried to have a new regulation to force everyone to replace oil heat with gas heater, with electric it was. And, this would be an enormous expense to people who would have to, retrofit their furnaces and just a kind of ridiculous thing. On the Germany, it reminded me of the fraud of biofuels. Because there was some push, and I'm kind of forgetting it now, of like replacing steel with like some kind of pressed bamboo structure. I forget exactly what it was, but it's good to use metals. It's a wonderful thing. It's fine to do that. And using biological materials in roles where they're not needed, to me seems kind of wasteful. Like I was bringing up the example of burning wood or biomass. Burning wood is completely stupid. or biofuel. You know, the amount of energy that goes into producing biofuel, ethanol, to run, you know, put in a vehicle engine, it's not a net. It's not an overall positive at all. You don't really get any energy out of this. You're throwing away cropland. You're putting all this effort into growing these, you know, biological things, right? Plants, and then turning it into something that's used only for its energy value rather than for something that's unique to its actual biological structure, like crops, you know, food, which you can eat. I don't know. It seemed like, you know, Angel may know more about other kinds of restrictions. Maybe we just don't know that much without answering this one.
Well, before I introduce the young lady who's calling us from China, let me just say I very much favor the professor's attitude toward many of these matters. I'll put it like that. We have Florencia Renteria del Toro. She's a 28-year-old student in astrophysics. Is that right? I'm sorry, advanced reactor physics, excuse me, at Harvard Energy Engineering University. So you're there. So why don't you go ahead? Because I think it is like almost midnight there. Am I correct?
Yeah. Thank you very much, Mr. Jason, and to everyone. It is a pleasure to be with all of you here, and for this invitation, and for taking this couple of minutes to just discuss what I did in the Mexican Nuclear Society conference. Well, I just prepared some contribution, what is named as methodology for Generation 4 reactor technology for selecting a potential nuclear power expansion with some sensitivity analysis. The main goal of this nuclear power expansion strategy is to determine what are the goals that we need to check for a future nuclear power expansion. So first of all, we have to identify the criteria if we are talking about if there is some existing CO2 emissions, what is causing these daily activities, or any other emissions, for example, like methane, and to plan how to mitigate those emissions that are caused by the human activity. After that, we have to consider those emissions and how to supply demand of electricity to suppress these emissions. But in the model that I designed, it should be considered the Sustainable Development Goals, which are dictated by United Nations. Some of the main goal is that I selected this goal 7, which is affordable electricity, because the main goal with this is to provide flexibility in baseload power. Afterwards, we have to consider different new reactors, for example, Generation 4 reactors. If we are talking about more molten salt reactors, select them as an alternative of models to include in this power expansion. It will be connected by a set of goals, as I mentioned before, in case of the reduction of emissions, supply constant amount of electricity. Either it could be construction, it could expand the model to other energy policies criteria. It's kind of flexible. And we have to look into the specifications that it defines every design aspect of the Generation 4 reactors. For example, we are trying to link neutron spectrum with coolant, temperature, pressure, the size of electric megawatts that is producing the reactor technology, and the potential applications or use like hydrogen production or district heating. So this model is based on analytical hierarchy process and analytical network process. It is one of the methods that also they use in aerospace industry or even in construction of nuclear power plants when they are intending to select a site for potential construction. Afterwards, the main part of the process is to base on the attributes to build the decision-making analysis for constructing a new capacity for the reactor type selection. With the software, we run the analytical hierarchy process simulation and we analyze the results. coming on into the comparison of the different models, the reactor technologies, and we come up with the best strategy, which one we have to select. It could be a pebble bed reactor or a molten salt reactor or any of the new potential models for advanced nuclear technology. I believe nowadays we have more challenges because other countries are trying to deploy the technology. But for newcomer countries into nuclear programs, it will be hard to identify which technology is better for them to deploy. So if we just try to make a strategic method that could be adjusted to their needs, it will be much better for them to see and to take the decision-making process.
Let me just do the following. Thank you for your report, but I just want to get either from Jason and also from the professor, because this gives us a way of sort of shifting for a moment into the realm of reality as opposed to a lot of the craziness that is characteristic of this whole issue. And that's one of the problems. And so I just like maybe, first of all, Jason, if you have anything, or Professor, just back to Florencia, but also I'd like to ask her, let's forget for a minute the the political atmosphere that tries to tell us that snow is black, okay? And let's talk for a minute just about the idea of energy and why you're studying, for example, nuclear power. You're from Mexico, you're studying in China, just a little bit like that, and then I'm sure they'll all be able to respond.
Well, I think nuclear energy is the best strategy to overcome climate change. Is the most reliable source of electricity in the world, and that can cover the demand of people around the globe. Even we cannot rely on solar energy or wind energy or hydro because not every country has the same resources. But nuclear offers the technology to be deployed even if it's in a desert zone or a dry zone, or even in a very cold place. So it gives that flexibility to cover that capacity, and it's also offering another applications like district heating or hydrogen production for the future, because we cannot just say that nuclear energy is used for producing electricity. It offers more benefits to the world. And in my opinion, it's one of the areas that we have to look at it for the next future sources of energy as well. Because let's look at the space. We are going into that area that we are moving into the transition of new sources of energy. So the better we study it and we keep improving the systems, the good things that we can bring for the future.
Okay, Professor, you have anything in response?
Maybe just one comment. I think that definitely nuclear power will be more and more important as years go by. However, I will not mention nuclear power as a way to fight against climate change. Because climate change is not an issue except for definitely not for mitigation, because we can do nothing against climate change. Climate has always been changing, so we need nuclear power because we need nuclear power, not because we don't want to put CO2 into the atmosphere. That's very important, because I think credibility of what is very important. If nuclear power sustainers say that we need nuclear power to fight climate change, I think they might lost some credibility. That's it.
Jason?
Well, I'd like to add a concurring view on that, which is that it's, what you had mentioned about the other benefits of nuclear, the ability for district heating, for hydrogen production. I mean, these are, space, you obviously can't use a windmill in space. There's no wind to blow, clearly. So, I think keeping a focus on the physical benefits of nuclear, which are tremendous. So, economically, because I think that there's so many sort of things that are put together nowadays in terms of we're trying to meet this goal and that goal and this goal, that the physical economic potential of reducing overall human effort, overall mining needs, physical processing needs, that nuclear is just so physically productive from that standpoint that, to me, that's sort of like the takeoff point of why it's such a great choice for the future. And I feel a little funny that people, because the whole like green sort of thing, it pulls so many fields together, and I don't think that it's necessarily the case that expertise in one field carries over to the others. Specifically, we have a combination of attempts to model the entire Earth's climate. That's very complex. Then we have economic considerations. What would be the cost of trying to reduce CO2? What would be the cost of saying, who cares if water levels increase? We can just build this and it's no big deal, or run our air conditioners more if it's hot. And then we get into, the energy resources experts who have a very good understanding of what the actual potential of nuclear is, about, pulling away from hydrocarbons from the standpoint of increased efficiency in producing hydrogen or other synthetic fuels from nuclear, to be able to effectively indirectly electrify or nuclearize these other energy uses. So it's very complex, and I think that it's very tempting to sort of assert an expertise or an understanding in all of these areas when it's more than is really the proper domain of that field, if that makes sense.
Okay, so we know that you may have to get going, Florencia, so is there anything else you'd like to say or any response you have?
Well, thank you very much for this space, and I believe we shouldn't look at nuclear energy as a threat for the humanity. It's more like a source of energy that has been working for such a long time, and we shouldn't criticize for all the benefits that offers to the humankind. It's better just to focus in the capabilities that offers the energy, rather than fighting against any other sources of energy, because both models of energy can work together, but it depends on the land that it is established, let's say the hydro capacity of the solar capacity, but we shouldn't demoralize or create negativity against nuclear energy. Thank you.
Okay, well, thank you very much. We have a question that actually has come from one of the people that will be on the panel later, which I'm going to put in now because I think that might give us something answering. This from Richard McPherson. And again, we'll be hearing from him. He's retired U.S. Navy engineering officer, and he was the U.S. representative for the IAEA six-nation panel, which went to Chernobyl back in '86. So here's what he says, and see what the comments are. Using the United States as an example, from 1900 to 2000, 100 years, life expectancy increased for men from 47 to 75 years, and for women from 49 to 80 years. How you had better food, water, healthcare, and energy. Why aren't Americans simply offering the same thing to the rest of the world? Think about the world results if we had pursued President Eisenhower's offer in 1953 of nuclear energy for peace and prosperity. So that's basically kind of a comment he's making watching the panel. And let's just ask Professor Battaglia if you have any comment about his comment.
Well, the energy is definitely the most important thing that we need. We must realize now, yes, he has made a comparison with 100 years ago, but we must realize that, for instance, slavery was not a taboo until about 200 years ago. The movie Gone with the Wind was taking place around 200 years ago. Before then, most of most of people were living in a condition of almost slavery. The Roman the Roman time, the Greek times, so 90% of the population was living in slavery. So the key word for the future of the humanity, or of a even ever growing humanity, is the availability of abundant and affordable energy. This must very well be understood.
Okay. Jason, anything?
No, nothing to add right now on that.
Okay, fine. So, Diane, back to you.
Yes. This, I think, is an important question to many of our listeners. Someone writes in the YouTube chat, is it true that Greta Thunberg is a paid CIA asset, talking on behalf of the New World Order, who want to depopulate the planet by 6 billion people and preserve the land for nature and not for farming or livestock? Related to that, who is promoting these lies about climate? Who is funding the promotion of these lies, and why?
All right. So, Jason, why don't you start?
Take a stab on that one. So, Greta Thunberg is not the ringleader. Okay, she's not making this policy happen. You got to look a little higher than that. And the place to look is the British Empire. So, look at, for example, Mark Carney, former head of the Bank of England, one of the biggest promoters of this Great Reset, Green New Deal policy. You know, the World Economic Forum is talking about the Great Reset. These are hardly, you know, what you might call, you know, leftist radicals or something along those lines. This is coming not from the left, which is a kind of a silly thing that some people think. This is coming from above. This is coming from the financial elites that run the greatest source of finance in the world, the City of London. It's coming from Wall Street. There are people who are going to make an awful lot of money off of it, but money is not the primary motivation. The view that there are too many people, as expressed by Malthus, this wasn't something that he thought in order to, you know, make money. This was a vision of the human species, that most people should live like animals or like slaves, and that there are only a few people that are really, you know, should be dignified and considered to be human beings, although they disgrace themselves by having this viewpoint, and that overall human population must be controlled, the world population must be reduced to below 1 billion. This is said explicitly by, you know, David Attenborough, was by Prince Philip. You know, this is their viewpoint, and this green stuff is a way of achieving it. Greta Thunberg didn't think it up. She is plainly a useful tool in this, but no, she's not the. There's better targets, like Mark Carney, for example, Prince Philip, David Attenborough, these institutions.
Okay, Professor Battaglia, any comment?
Well, very little comment. I think that nowadays, since there is available this new technology like wind power and photovoltaic technology, this technology is available. They have to sell it. The amount of money that this technology cost is huge. It's very huge. Photovoltaic cells should be sold in a jewelry shop. Then, nevertheless, all these technologies, as far as energy production concerns, are really useless. One must understand how energy works, and then if you want to understand how we use energy, then we realize that these technologies are useless. However, they are there. They have to be sold. Who sell these technologies makes a lot of money, so they have to. I think they have to rush to make all this money before people realize that these technologies are useless. I think that this is also part of the story. There are also many, obviously, different views of the world, different political ideas, but I think money whenever there is something which is nonsense, one has to look where is the money.
Yes. Okay. I think we have Andy Olson on the phone. He's a Schiller Institute farm leader from Minnesota. There he is. Andy and I believe in November 30th, 1989, we were somewhere in Berlin on a wall before it fully came down, which we tried to help it do. How you doing, Andy? You're muted, we think.
Okay, can you hear me now?
Yes, we can hear you. We can hear you. So go right ahead and say what you have to say.
Well, as far as the wall, we were maybe, it was a dangerous situation and we were trying to take the wall down, and maybe we shouldn't have been doing what we were doing, but it was a great time to see how the world was changing, and unfortunately the world didn't change the way we wanted. And this electricity business is very alarming. I've appreciated the Senator Thompson and the German electrical expert, and all this about electricity exchange. And I don't quite understand electricity, that it has to be balanced. The demand and the supply has to always be balanced. Well, this destabilization that has occurred because of renewables is alarming to me, and I don't quite know all the ins and outs of that, but I'll end at that and listen for more questions.
Well, before you do that, why don't you say something to us about, you've been documenting a little bit of this, of what's been going on in Minnesota, just so they have a little background and they can respond.
Well, the way this was set up, it's a classic divide and conquer on the part of those that are trying to force this renewable energy onto us. So 42 million Americans get their electricity from electrical co-ops, and most of them are rural, but those areas have now, some of them, become suburban. But they have no involvement in the promotion and construction of all this renewable power. The multinational corporations or the representatives of the international banks are running around trying to sell the idea to landowners to put up a wind turbine, and recently a solar panel. And then neighbors don't like the sound and don't like this, and so there's a conflict between the owners, or where the renewable energy is located, versus the neighbor that is right next to it. And so this is it has to be arbitrated by the county commissioners. They're the ones that have the authority here, and they're cultivated, you might say, by the renewable energy institutions. So for us to stop this thing, it seems like it's almost impossible, because they come in with their bucket trucks and their cranes and their excavators, and it's a tremendous amount of energy and effort that is going into the production of these. And I should say one thing about the renewable energy fields, the farms they call them, that they're all located on these transmission lines as opposed to these baseload power plants, which it's real that they're cutting it down, or decommissioning some of these baseload plants, which is really alarming. But the age of these, Senator Thompson, I think, said the average age is about 12 years, and that's what really is I see happening here, is that these wind turbines have been up for about a dozen years and nothing is reported. All of a sudden, the big equipment comes in and the cranes, and they completely take down the generator and the blades. The only thing they don't take down is the tower, and they replace it with new. After 12 years, it's a huge, huge waste of resources. And you talk about energy that's not dense. This is about the least dense energy you could ever have. And it's really alarming to see. There's been a nuclear plant in northeastern Iowa at the outskirts of Cedar Rapids that Next Era Energy, after the derecho last August 10th, the cooling tower was damaged, and they used that opportunity because they had already purchased a 71% interest in this plant, and they just shut it down, and it's never been opened up again, and it had permitted to 2034 that plant would be good till then, and in 2020 they shut it down, and that really crippled the energy grid as far as reliability in our area. That's just one example, and there's other examples where they're doing the base load. It's not just building of renewable, they're taking down base load in the process. And what this is doing, it's really making our grid fragile, because when the wind doesn't blow and the sun doesn't shine, you don't have electricity unless you have base load. And this is a duplication. This is the craziest thing that could ever happen. If you ever wanted to destroy America, this is the way to do it. Because once they get this mixture of more renewables and less base load, we'll be conquered, and no army will be here. They'll just destroy our society. As far as electricity is one of the most paramount, the most important, reliable infrastructure any nation could have. So I'll stop at that.
Okay, very good. So let me ask for a response from Professor Battaglia. You have anything you'd like to say?
Well, yes, I think is very right. But I wouldn't be actually so I wouldn't worry so much about the reliability of the electric system, because they are building all these useless structures, but they have to keep there the coal or gas or nuclear power. I mean, for instance, Germany in the last few years has after what happened in Japan at Fukushima, which actually happened nothing nuclear-wise speaking. Happened a lot because of the earthquake, of course. So after Fukushima, Germany has shut down a few nuclear reactors. But what they did, they have increased the electricity production from gas. They have imported a higher amount of gas, because there is no way that can replace one single conventional watt with 1 gigawatt of photovoltaic cells plants, or 1 gigawatt of wind turbines.
Okay, very good. Jason?
I just think that that's good to get an on-the-ground report this is what this stuff really looks like. Sometimes people imagine, wind in the abstract, and they think about it, and then you find out, well, what's it really like living with these things, and how reliable are they? And one of the things about just to respond to a question that didn't really come up today, but often does, which is, are the fossil fuel companies trying to hold back progress? Are they stopping nuclear in order to maintain their market share, let's say? Just, in listing the people that are promoting the green stuff, one of them that surprises people is some of these hydrocarbon companies, because if you're building a bunch of windmills and solar panels, you're guaranteed you're going to have to build a natural gas plant to go with them, because they're unreliable. So to compensate for the unreliability, you got this additional capital expense of a natural gas plant, and so who's going to be building that natural gas plant? So it's it's a very bizarre thing that some of the larger stations that are not as dispatchable get shut down in favor of ones that are sometimes less efficient, but which can move around with the uncertainty of solar and wind. You sort of say, as a grid, like if the goal is overall to provide electricity and energy to everybody, how do you achieve that? And I think starting from that standpoint just sort of helps make clear that thinking about these things in terms of like one energy producing object at a time, like one windmill, misses what's so especially bad about this stuff in terms of how systemically useless they are.
Okay, so I think, Andy, were you going to respond? Just go ahead.
I would like to say one thing about natural gas. It seems like that's the panacea for renewable energy, and that's what these people have done. In like in Minnesota, the XL Energy, they retrofitted 7 coal plants to natural gas. And what happened during the Texas disaster is that natural gas, it's so speculative with this electricity change that if you want to buy spot market gas at a high demand time, it's almost prohibitive. And some of these regional co-ops would not touch their gas valve to start their peaking plants because it was too expensive. And what they had as a backup then was fuel oil tanks, considerably large fuel oil tanks, and that's what they used. But to fill those fuel oil tanks, there's no pipeline in the rural area out here. They have to use semi-trailers, tankers to bring this in. And then after a period of a year or two, this fuel gets old and then they have to sell it and haul that out. It's extremely inefficient. So I think that gas is it's more overemphasized than how great gas is going to be, because there's no gas stored next to a power plant. It's a pipeline that has to bring it there. And in this Texas situation, in Minnesota, we didn't have any outages, but the gas price was $800 million to pay that gas price for the consumers, and the consumers stood it. It wasn't the corporations.
Okay. All right, fine. So I think thanks a lot, Andy, for the report. And of course, the whole panel is, I think we've done this so far today, is to provide people the kind of ammunition they're going to need to take some of this on. I think we can win these fights, but I think obviously it's going to take exactly what we're doing today and the numbers of people that are watching and participating today. So thank you very much. Diane, I think you've got another question.
Yes. This is a question about nuclear waste as an energy source. The person says, it seems obvious that recycling existing stockpiles of quote-unquote nuclear waste to fuel for fast reactor production of energy oh, that's a sentence. It is a proven technology, and the current stockpile in the U.S. will provide at least 200 years of electricity demand. It's clean, 100% domestically available, and provides an energy extraction increase of 30 times. Why aren't we doing this?
No, I don't know why we're not doing it, or what the fear ever was. I mean, I think that it was in the 60s or 70s that plans for reprocessing waste in the U.S. were kiboshed. Overall, in terms of fast reactors, the uranium that we mine, only a small portion of it is naturally fissile and can be used in a fusion reactor. But the rest of the uranium in a fast breeder reactor can be turned into a fissile material. So overall, this technique of using fast neutrons to turn the non-fissile uranium into a fissile isotope would be a way to dramatically expand our uranium reserves and to get more bang for to get more energy out of the uranium that we do mine, and it would provide a way of dealing with reprocessing, reusing portions of what's stored as used nuclear fuel today. I don't know why it didn't. I think I'm just kind of gonna guess here. I think that maybe proliferation or concerns about plutonium may have been part of why it was sort of poo-pooed or not used more around the world. But that's kind of a guess on my part, because I think that's why thorium is promoted in this way, because its proponents say, hey, this can't be used to make a bomb because there's no plutonium, whereas fast reactors with uranium would be making it. I think. Maybe I shouldn't go on a limb when I don't know, but that's my take.
I'll just indicate that I believe we'll be talking about that in the second panel. And one of the presenters is certainly going to get to it in the question and answer period. So I would advise the person to tune in for the second panel, and you'll get the answer to your question. Professor, if you don't have anything else, I'm going to ask a final question. You're good? All right. So this is from a student. This is from Kynan. He just says this, and in part this has been addressed, but I think this sort of useful to bring us to a kind of conclusion point. I want to thank all the panelists for the extensive and thorough presentations. All of this proves that the so-called climate agenda has little or nothing to do with actually preventing climate change, but with enforcing a global depopulation policy in which people across the world will no longer have access to reliable forms of electricity, food production, etc. I think a very simple question which could be asked is why governments consider this to even be a threat, but they're opposed at the same time to the use of thermonuclear power and nuclear power. Why is it that there is barely any funding for our fusion program, for example? That recent blackouts in the United States have recently shown us what could happen if our conventional power sources are largely replaced with ineffective windmills and solar panels. Are people waking up to this reality? Is there now a moment in which we can actually change the dynamic in the world and create a new era of prosperity, development, and scientific advancement? So that's his question. So let me ask Professor Battaglia if you have anything to say to that.
I think that, the answer could be that nobody can fool everybody forever. As somebody else has said better than how I'm saying it now. What people should realize is that there is first of all, we need to turn into a world where electricity is even more important. As time goes by, electricity becomes more important. Now, to produce electricity, there is a very rational way to do it. The base demand should be provided by nuclear power. The normal demand above the baseline should come from coal. And gas, natural gas and hydropower for the peak demand. This is the rational way to do it for technical reason. I think in the panel later, all these things will be explained better.
Okay, thank you. Jason?
I agree with what Professor Battaglia said, and I also agree that this will be taken up more in the next panel. I mean, I think leaning on it as a contradiction is really important. Like, okay, so the Sustainable Development Goals created by the UN, right? It sounds very nice. Development goals, having development is great. You throw in the sustainable, you get some issues because they contradict each other. So, to try to eliminate poverty, to provide energy, ensure there's no energy poverty, this runs into some of these, so-called climate goals. They contradict. And, to me, the question that you just posed from Kynan is one of the, it's sort of like one of the most obvious ones, which is why is there the attack on nuclear? In terms of why nuclear was attacked even before global warming, was used as back when global cooling was supposedly a threat in the 70s, there was already attack on nuclear power. So why? And that's been pretty consistent in that there's been just a sort of a completely insane terror campaign of telling people that whole areas like the size of Pennsylvania could be, made uninhabitable by a nuclear disaster. That Cleveland could be, what did Ralph Nader say? Cleveland could be blown up and the survivors would envy the dead. It's just over the top nonsense. These are not nuclear bombs. And I don't know if people are so afraid of nuclear war that they, put their feelings on nuclear reactors instead. But the history of the attacks on nuclear power, I think, go along with the development of this sort of explicit neo-Malthusianism that really took off in the 60s and the 70s, and this deliberately induced cultural despair. The CCF, ugly art garbage, attacks on the ability to exist in the future, attacks against the space program, saying, we shouldn't be doing this, and we have problems here. Why think about space when we have problems here? As though, there's a contradiction. So it was a paradigm shift that Lyndon LaRouche identified and fought against in a very specific and powerful way through his life, and that's a fight that we have to win today.
All right, so we're pretty much at the conclusion, and I just ask if Diane, either if you have any other questions there or if you have any comment at this point, since this is the only time you can go off your moderator position to say anything.
I would just, again, encourage everybody to look in the description box and become a member of the Schiller Institute. I think that's very important. We have to obviously fight this policy, and part of the reason that they've gotten as far as they have is because people weren't aware of what was going on. People believed some of the lies, and people have come to accept really the onslaught starting in the 1960s of the idea that quote unquote small is beautiful. We should reduce our impact on the environment, as opposed to remembering that human beings and the human mind is, in a sense, the crowning glory of creation. And that's what we're fighting for. And it's something that's a right of every single person on this planet. And we should have the idea that we're going to spread it throughout the galaxy. So I would just urge everyone to become active. We have nothing to lose by fighting, but we have everything to lose if we don't fight the policy.
All right, so I want to thank Jason Ross and particularly Professor Francesco Battaglia for his participation. He brought a bracing Boccaccio-like realism to some of the questions. And we want to invite everybody to join us for our second panel, which will start at 2 p.m. It's called Energy, World Health, and the End of War, the Power of Energy Flux Density. So we'll see you at 2 p.m.